And we got, okay,
Good.
Sorry.
that's okay.
Sorry.
So, we're on a roll here, and it's really hard to, as somebody that grew up in the Apollo era, to watch the Apollo 11 liftoff was a monumental time frame. And, we're, I think in the tail end of my lifetime, we're going to see a revisit of the moon and more aggressive action about permanence and how do we put up a base on the moon and set up shop. John?
Yes, sir. Everything okay?
Can we get rid of that thing? Got it. Okay, I got that. Okay, the next thing that happened, I told you last time we met, watch the Chinese. It's always fun. They did launch their Shenzhou 14 crew, 3-person crew. They're up on the space station, the Chinese, in construction. This thing is being built as we speak. And so they're up there now, a 3-person crew. Next slide. Here they are on the core module of the space station. The big thing that's going to come up this coming week, keep an eye on it, is I think it's on July 24th. I think is where they're going to land on launching this next slide. It's a new lab module. They're going to add on to their space station. The crew that's on there has got a lot of work to do to position spacewalks and make sure this thing is attached to the core module of their station. There's another lab module to go up. Let's see, what did I write? I think it's October, November sometime. It'll be toward the end of the year, but there's another module sort of like this. This one has a lot of life science experiments on it. Centrifuge and some other stuff. And it's pretty cool. It's not as big as the International Space Station, but, it's really, kind of confined operations, but yet they're building this station that will be done by the end of the year. If all the launches go off, there will be another human space flight after this launch of this lab module. It's piloted. And so they're going to have a crew exchange. It's getting busy up there, and keep an eye on that. It's pretty cool. Again, not as huge as the International Space Station, but as our space station becomes tired and, problems are happening, it'll be deorbited. And so China is really could have the only station up there at some point in time, but we'll see. It's a big game and a gamble, but keep an eye on that. Next slide. So end of the year, this is sort of what it's going to look like. End of 2022 is what they're promising. They got other supply module that has to go up and some other stuff. So it's I'm amazed, that from a country that didn't have a human space station capability to where they are today is pretty fast paced. So again, I think it's something to keep watch on. Next thing. We have a incredible space plane up there. Nobody's really paying attention to anything, but the Air Force has got a robotic space plane that's been up there. It just set a new record, and I can't remember the name, the days that it's been up there. It really broke a new record. It's launched in 2020. and it's just up there. Nobody knows quite what it's doing. It had classified payloads. It did some early deployment of a satellite. It did some other things. Again, it's robotic. There's nobody in it. It's been up there for quite a while, and it just broke the last record for the program. It's pretty cool, and the Air Force is really not talking about it. I was able to get the Pentagon to tell me that it actually broke the record, and it's a very interesting development in military space activities with a robotic craft that has classified missions on it. Next thing. Russia is doing some really interesting kind of simulation thing. They have a thing called Sirius, and it's on the ground. It's in Moscow, a big bunch of containers put together, and these people just went through, what did I say, 240 days of living inside this thing, 5 of them, and they simulated a lunar landing, kind of long duration space flight, and I think they're still talking to each other. I don't know, but everything seemed to work very well. And the cool thing is, let me read my notes here. The cool thing to me was it's Russian, American, and Arab participants. It was a really international crew that was picked to be inserted into this module and just survive 240 days of being together. And just to, the Russian life science people are kind of primo in the world community, because they really grill these people while they're in there for that length of time. And it's pretty interesting, but they just came out a couple weeks ago after 240 days. Next thing. Kind of an interesting development in, we've heard from Alan Stern from Southwest Research Institute. Alan was the principal investigator of the New Horizons that flew beyond Pluto and investigated Kuiper Belt objects. And it looks like everything is really going forward on a whole new kind of dynamo of this mission, robotic again, and it's going to do some pretty cool planetary science, heliospheric science, some other things that it will be doing. But Alan, I talked to him the other day, and we had a really nice conversation about what the premise. Maybe Bob Grimm can fill in on some of that. But New Horizons is moving on. And one of the things that's going to look for Kuiper Belt objects from a distance, and maybe if one is close enough, it will maneuver to take a close-up look. So anyway, next thing. I know I badgered you people about UAPs, and I thought I'd just give you a little update. Congress just last week, week and a half, something in there, authorized an entire new capability to have people send in their sightings. And so Congress has really stepped up to this unidentified aerial phenomenon. And, nobody knows what we're dealing with here, but, the bottom line is Congress has taken a lead, and in the defense authorization bill, they've actually outlined a whole new capability to have people send in their sightings. And so we're on a roll here with something. What this is, God knows. It's interesting. This has a legacy with UFOs, and we're talking about when people go UFOs, they think of Roswell and dead aliens and, crawling out of the, who got, how many alien bodies out of that thing. I think this is a separate phenomenon. This is something else going on. And we don't know exactly what it is, but the fact that Congress has really taken this on as an actual place to send in your outlook on UAPs is pretty interesting. We'll see where this goes, but I'm watching this pretty heavily. I have a new article coming out about NASA. NASA has actually gone on board to help investigate these phenomenon. And I don't know what we're dealing with here, but it could be a totally different kind of atmospheric phenomenon, something else going on that people are rallying around, and we'll see where this goes. But it's a fascinating topic, and it gets back to the Jim Webb Space Telescope. In some ways, are we alone or aren't we? I think that's it.
That's it.
Thanks a lot.
Everybody's muted, by the way. If you have questions, you can unmute yourself. And I have to do that to minimize background noise, but ask away.
Yeah, my guess, Leonard, is that NASA should, I'm in favor of NASA looking into these UAPs, and I think that much of the funds should go to a psychologist. I think that's the answer to what's going on, most probably, not for sure.
Yeah, I don't know. I think there's something here, and I think, in some ways, it could be preparatory to us accepting that we're not alone. I'd like to think there was a link there, but I don't know what the link is and whether it's a hazy link or whatever it's going to be. But, Avi Loeb and Harvard, and there really is a bunch of new studies underway that a lot of people don't appreciate yet. But
Leonard, I believe in UFOs before I believe in Avi Loeb.
okay.
I was just going to ask what
Yeah, right.
Clark and Bob maybe thought of Avi Loeb.
Well, I don't know. He's kind of a grandstander. Kind of crazy.
Alone?
Wants to sell books.
Oh,
Yeah.
me too, but sorry.
Yeah, there's a lot of grandstanders in this community.
So for everybody, if you don't remember, Avi Loeb did a paper, wrote a book. He's where is he at? Harvard?
Yeah,
Yeah.
So he is a big proponent that Oumuamua, the interstellar asteroid that kind of zoomed through the solar system a few years ago, was really an alien thing, that it wasn't natural. So that's who that Avi Loeb is.
yeah. Now we're on to something going to come out of this. I don't think it's a negative. It's really getting people to acclimate a little bit. I think the word is acclimate to the fact that we're not alone. And I think any of these things, even though they're suspect in many ways, I think gets us ready for the big message that's coming out of eventually out of Jim Webb, I hope. I don't know how. What do you think, John? You're going to go a little bit into the just a few things about Jim Webb Space Telescope, and one of them was exoplanet investigation. How do you see that?
Well, so I'm going to talk about James Webb here in a second. I didn't include the exoplanet spectrum because I thought it was a little esoteric, but
Yeah,
so James Webb is the new telescope that we've been waiting for. This will replace, I keep muting Jan, but alien talk. I don't know what's going on there. But anyway, the James Webb, Hubble looked at the universe in visible light, some infrared, but it was mostly visible light and ultraviolet. The James Webb is looking at the other end of the spectrum, looking at infrared. And what this has, what this means for exoplanet stuff is, this is where infrared is heat. So we're looking at the birth of stars, and it has some incredible resolution. So we can get some, as the exoplanet moves in front of the star, we might be able to get a glimpse. And it looks like they did that from the image that they released the other day, some spectra, and figure out what's in the atmosphere. Similar to what we do with the sun, we look at absorption lines of the sun and other stars to see what elements are present. So with this James Webb, we can see if water vapor is present in the atmosphere or methane is present in the atmosphere and these kind of things. This is very exciting for exoplanet research, and maybe Bob will talk more about that with the decadal survey stuff. But let me go ahead and share my screen and we'll talk more James Webb. Did anybody see the, oh, before I dive into that, we have an opportunity tonight. David Elmore has a telescope down in New Mexico that he operates remotely, and he's going to be looking at the, correct me if I'm wrong, David, he's going to look at Eagle Nebula tonight and do some observations, and we have an opportunity to look over his shoulder. So we're going to keep this Zoom meeting open. And if you want to stick around, he's going to start that about 9 o'clock. I'm going to hand off the hosting and it'll continue to record so we can see it later if we want. But it's an opportunity to see, what he does. And then maybe later, if he does any post-processing, we can see the results of this observation session. So before, I didn't want to forget that. Sorry, David, about that. Can you guys see the web image or the web?
We see a title bar.
I
Yep,
see your
right
title
here.
screen.
Oh, you see, okay. So this is not the web image. This is a Hubble image. NASA released 5 images the other day, and I don't know if anybody saw the briefing with the president. Was the weirdest thing I've ever seen on NASA TV. But
Yeah.
Bill Nelson, the NASA administrator, went kind of. I'll show you the image they showed. That very first image they shared the deep field image first, and then the next day they released this. This is the Southern Ring Nebula, and this is the Hubble image. And so you can see this is again taken in visible light, and this is what James Webb is seeing. So much clearer, but also it has so much more depth because it's seeing the infrared, the heat of this nebula. And I've tried to position it so it's basically the same. And it's just amazing the detail that we're seeing now. My favorite part of this image is, in this image from Hubble, you don't see anything in the background. It's just night. And yet there is so much more of this nebula, including that far off galaxy up in the upper left. I thought that was pretty cool. The bright stars are stars that are in our galaxy, and this nebula is in our galaxy too. And they're closer to us than the nebula is. If I'm right, if I remember correctly, this nebula, oh shoot. It's this one that's 8,500 light years. They're calling this the cosmic cliffs. Again, this is a Hubble image, and this is the James Webb image. And there was more to it, and I should have included it, but there's all this information in the cloud below, and so much more detail in the blue area where the blue area is hotter gas than the reddish areas. Anyway, and if I'm right, this is it's glowing blue from the stars that are being born inside this nebula. This is part of the Carina Nebula. And they showed this, this is Stevens Quintet. This is a side-by-side image. The one on the left is the Hubble image, and the one on the right is much more detailed, showing more of the star creation areas, especially like in the middle, there's that kind of spiral galaxy, and it's got this splash of red arc on the right image. That's all star forming regions, and they're those young stars, they are glowing, you know, with some warmth, and that's why James Webb is picking them up. And I was pretty surprised at all the blue stars in the one in the upper left, and then there's still the amorphous kind of glowing going on in the upper right galaxy. This is a very popular group of galaxies that even amateur astronomers take pictures of. Oh man, what happened? Oh, I didn't have the best image of all. Oh no.
While you're recovering, let me just say that I thought that was a really interesting image, John, because I mean, the other ones clearly showed just how much more awesome JWST was. That one to me looked like it just had different information. So I thought that was very compelling.
Well, and you know, what's cool about these, I was kind of bummed. The Hubble's been around, what, 30 years now, up in orbit. We can't repair it anymore, so it is what it is, but it's still delivering great science. And they were kind of, I don't know, some of the side-by-side images that I was seeing, I didn't finish my PowerPoint, so let me put these in here real quick. But they were kind of poo-pooing the Hubble images, and they were the side-by-side. Hubble's still pretty cool. James Webb is much, much, much more detailed for sure, but some of these Hubble images are still pretty doggone amazing. And so I'm always a little bummed out when they don't compare them quite right.
Yeah.
Give me 2 seconds, folks, sorry. All right. I got to talking earlier, didn't finish up. Any questions about what I've shown so far?
Yeah, I think we got to realize that these, 4 or 5 images released is the beginning of a cascade of where we're going, and even fine tuning the James Webb Space Telescope. So what should we expect? Have they talked about what next?
Well, so I didn't read this article very closely, but they have more images that they didn't choose, and they haven't shared what those were. These are the James Webb isn't like an Earth-based like the Anoia Solar Telescope where I work and what David's worked on in the past. The Anoia Solar Telescope, we've released maybe 3 images in the past year. One of some solar granulation and one of a sunspot. We haven't, as far as I know, we have not moved to the limb to look at a prominence. We haven't looked at, there's just a lot of vetting that goes on with the instruments. When you launch a satellite into orbit, you can't, those instruments have to work like from the get-go. So they've already been vetted and tested and everything is looking great. And so I can't imagine, they were pretty lucky, I think, in the fact that, the James Webb is much bigger than Hubble. Hubble had 1 mirror. James Webb has 10 that they have to coordinate. And what this means is, it can launch small, and then they opened it up. It just kind of folded out. And so they were able to do that. And so I can imagine that if these are the first images that they provided, the next images that come out in the next months are going to be even more incredible. So yeah, let me share my screen again. Let me start this slideshow. But the image they released first, oops, where you get this again. this is the Hubble image. This is the deep field image from 2014. And at the time, this was the farthest. Remember, when we look out in the universe, we're looking back. in
Not seeing
time.
anything.
Think we see something other than you, John? We do not.
Oh, sorry. My bad. I was getting all excited there and y'all. Oh, shoot. You see.
Thanks, Ted, for sharing that link.
I'm sorry. I'm having problems. I'm showing it, but it's not showing nice.
Let me tell you a little story while you're figuring that out. I tell you, one of the things in my career in Washington, D.C., when I had to cover the Hubble Space Telescope, was the failure of the mirror and the problems they had. And I tell you, when I went back and thought about Hubble and the problems it had and how it got to where it is today, it's pretty amazing. And we got this incredible capability. But one of the problems NASA has is promising you the face of God. I don't want to be corny, but I mean, a problem that we have with these space telescopes is that they are billed, they are advertised, they are promoted, they are put into the public face as like, we're going to see the face of God and we're going to go back in time. They're time machines. And when it doesn't happen, it really was a crippler for Hubble. It was just a time in reporting where they just jerked the face of God out of our purview. And it was tough to write about. And with Jim Webb, this thing has gone through hell and high water at 10 billion plus to do what it's doing right now. And so, the expectations are high about what this can do. And one of the problems I had with all the narration, you need astronomers that are very, very good on explaining what the hell we're seeing. And I think your comparison with Hubble is right on. We need to know what our $10 billion got us.
I think that's where that press conference, or wasn't a press conference, the briefing with the president the other day failed on so many levels. So this is the image from Hubble, and this is the image from Webb. Now, they're a little different, but this is the image they showed very first. And what is amazing to me is I think that the NASA administrator was trying to convey this, but one, we didn't get this full image on screen. It was just like everybody looking at it. And I really wanted the president to jump up and go, oh my gosh, that's the most incredible thing ever. But he didn't do that. But anyway, so remember, we're looking back in time. And the way the NASA administrator explained this image and the way that I've read it online with NASA on the site is that if you held a grain of sand out at arm's length, that's the spot in the sky that James Webb is looking at. Hubble's is a much bigger field of view, and they're not seeing some of the galaxies that we're seeing in this image. The stars that are bright, they're in our galaxy. But some of the really red, faint galaxies in this image are pushing 13.2 billion years. So it's taken 13.2 billion years for light to reach our eyes, traveling at 186,000 miles per second, 6 trillion miles a year, 6 billion miles a year, whatever. And anyway, it's taken all that time. This is if the universe, right now we think the universe is like 13.65 billion years, and there is a time when we won't be able to see about 100,000, 200,000 years after the universe was born. There, it was opaque, and it was not until after that that we can see. So we won't be able to see the Big Bang because it's just not possible. But these things, these arcs are, there's the quasar in the middle, I suppose, is such a strong gravity well that it's causing, those arcs are actually galaxies beyond it that are being deformed and by the gravity and thrown out to the side. Einstein predicted this, and how incredible is that? He couldn't have nailed it any better. And we saw a pretty good detail with the Hubble image that we have here, but it's just, you know, what we'll be doing with the infrared, the beginning of the universe is warmer or is warm, so we'll be able to push that back even farther, and perhaps maybe God's face will show up and Leonard will be jumping up and down and going, "That's incredible."
Yeah.
Anyway, what lacked in this thing the other day was just this, this is the tiniest, you know, this is a grain of sand spot in the sky, and we see all these galaxies. That's all we see everywhere we look. And so we can't help but see more incredible things in the future, because where do we even choose to look? And I think that's going to be the biggest challenge. And just like any other telescope, space telescope and telescope on Earth, scientists will be able to ask for time on the telescope. They'll be pointing it at exoplanets. They'll be pointing at galaxies. They'll be pointing it everywhere and anywhere. And hopefully some cool ideas of how, you know, cosmology, the origin of the universe, and if we're alone, because certainly we're not alone from a galaxy perspective.
Yeah,
So Hubble collected for about a week. Do we
yeah.
know how long Webb collected for?
This was hours. I can't remember how long, but it was not the week long or the, you know, it was
12 hours.
the hours, 12 hours. Is that what it was? I know that it wasn't very long. So those 10 mirrors have huge light gathering capability. It's going to be pretty cool.
You know what, you know, when I look at that image, you know, I've seen a lot of Earth imagery from the International Space Station. And when you look at that image and you think about looking down on city lights on the Earth, that to me is comparable in some weird way. It doesn't make sense, but I'm just saying that, you know, there's something in this picture that is very compelling about life in the universe. And I think it's very, very similar to looking at flying over cities on the Earth by the International Space Station.
Perhaps we should ask Frank White, who spoke to us about the overview effect.
Yeah.
You know, if these images, you know, have a similar feeling with the general public or other astronauts. Huh.
That's good.
I'll send him an email. I'm curious.
Ask him.
Anyway,
I'm kind of surprised that the public has reacted so positively to this image, because this image doesn't look a whole lot different from images you take of the sky from the ground or from Hubble.
Yeah.
And that's because of the fractal nature of the sky. My guess is that Webb is going to turn out to be much more impressive in terms of the scientific results that it will deliver than these comparisons of Hubble with Webb, because of that fractal nature of the way the sky looks.
Clark, you're good on journalism too. I mean, what is it going to take for people to understand that. And who is going to give us the best appreciation of what we're looking at? Because I think we're missing some key people here to really unravel the photos.
Maybe somebody like yourself will
No,
solve that problem.
no, won't be me, but I mean, I'll be quoting somebody.
You guys know if this is anything like Hubble, there's a huge list of scientists that are signed up with intricately detailed, slots of time to observe what they want to observe. And there's committees that allocate the time, and it's not just taking a bunch of pictures and who's going to say what they mean. It's pretty well all worked out.
Yeah, but what's weird, Bob, is that the scientists have been pretty quiet. I haven't seen Neil deGrasse Tyson go agog.
Well, Neil deGrasse Tyson isn't a scientist anymore.
Well, I know that, but I'm just saying, as probably the most known.
Oh, he'll make a whole show on it and make $1 million.
Well, okay. I'd like to be a part of that.
It's too early to have the first science paper or nature paper out of it.
Well, I understand, but I don't know. Like, I can guarantee you that for the Anoia Solar Telescope, these first images are going to drive, the very first images would drive many papers, which makes it my job more difficult to communicate this to the public because everything's embargoed. But anyway, Bob, we're taking away from your time. We need to.
That's right.
Any more questions about the James Webb? We'll show more images as they roll in the future, so don't worry about that.
I have a quick question for Leonard about something he was talking about a little bit ago. Do you know if NASA was commissioned to study UFOs or UAPs, or if they offered up to do that?
As far as I know, Bill Nelson had a early experience with on his Senate committee when he was there to grovel with the UAPs, and he's talked to Navy pilots himself. He feels there's something there that we need to identify, and he carried that into NASA and then turned it over to Zabrukin in the space science community to try to pull together some kind of study that NASA would not be looked at like cockeyed, because I think there was some worry that NASA dove into this UAP thing. They're going to get kind of blacklisted or something. So I think they wanted to be very, and they had a whole press conference about this thing of NASA diving into the UAP thing. It was not a small deal to do that. And so they're moving on, and that study is underway with a guy from Princeton and, some leadership. So we'll see what NASA is really going to come up with here. But it's one element of something else going on. And the government and, the Pentagon's involved, the Air Force or the Navy. I'm not sure about the Air Force yet. We'll see, I guess. So I've been really following this because it's fascinating to me because I do think at the end of the day, this thing is tied to something like the Jim Webb Space Telescope. Are we alone? There is a philosophy about, what's going on. Maybe there's somebody directing all this that's trying to get the public, doing some head rubs on all this stuff and getting them involved. But anyway, NASA will come up with something. Avi Loeb, I don't think him. I think he's part of the issue, but I think there's a lot of other groups that are watching this thing, and it's a very fascinating story. Watch my
Remind us,
space.com space.
remind us again, Leonard, who Bill Nelson is and Zabrukin.
What was that?
Remind us again who Bill Nelson is and
Zabrukin
who
is the head of
Zabrukin.
space science for NASA.
Mhm.
He's really engaged with with this effort, and there are two other people that were identified in and I can't remember their names, but they're one guy is ex-Princeton guy, and they're all highly qualified people. They're going to be putting together a study. The bad news was the amount of money that's going into this study is pretty minimal. And so the UFO fanatics out there are all critical because, they don't have enough money to do a good study. But, data is data, and we'll see what they come up with. And, at the end of the day, am I wrong? Meteorites, we didn't even know what meteorites were some time ago. And there may be a phenomenon that we are not aware of within the Earth's atmosphere that we should understand.
You're
Same
going to
with,
make an analogy to the early 1800s.
yeah,
Because Thomas Jefferson said, it is easier to believe that Yankee professors would lie than stones would fall from the sky.
there we go.
And he
There
was
we go.
alone even then.
Yeah. And look at the what are those sky bursts, or what are the other atmospheric things we just found not too long ago? Kind of a new kind of phenomenon. So I'm open for anything. I don't know if I need aliens coming here and trying to get in the front line of the grocery store. I don't know.
Sprites, what Ted
Thank
is
you.
talking about. Well, it's funny you say that. One of the things they led with for the image of the deep field of from Webb was the fact that I have a book, textbook from the 1920s that says, or it describes planetary or galactic nebula. So that we didn't know that galaxies were, we hadn't proven yet the galaxies are outside our own galaxy. So there were lots of ideas about this, and so this was just 100 years ago that we are saying, and now we're looking at the edge of the universe. So I think this is part of the story with the James Webb, is just like everything else in the 20th century and the 21st century now, we're moving really fast when it comes to understanding the world and the universe, and definitely our place in it. It'll be exciting either way.
Yeah.
What you're saying about the lack of science in these first 5 images, I mean, the science is there, but this was PR, this is politics, this is selling. In retrospect, this is why we did it. This is why we should be allowed to do more things, because we did good on this one. And so the science will follow, but right now it's all for wow factor.
Agreed. And you know what? Holy smoke, wow. So far, so good. I approve of this spending of $10 billion, but at the time when they were saying how much it was, I was like, oh man. Anyway, sorry. We can go on and on about this. Bob, you ready?
Sure, am I ready to share?
Anytime.
He's got headphones
Let's-
on. He's ready to go.
Yeah.
He says they hurt his ears, so
Let's do it this way.
they make you look smart though.
Right. Okay, can you guys see that?
Yes.
Okay. Well, it's thrilling to be able to talk about, JWST tonight, because, it's like the biggest thing with NASA in a long time. And the 10+ billion, nothing in planetary science unless Mars sample return balloons to twice to what they expect, will rival that in terms of the investment. So, I mean, JWST is worth talking about. So, but I'd like to follow up here with talking about the recent planetary science decadal survey. So this, I'll talk more about the purposes and how it comes about, but basically it's a blueprint for NASA's planetary exploration program for the next 10 years. That's commissioned. NASA pays the National Academies of Science to do this, and they organize it. They gather all the people to be on the committees, and they report it back to NASA. And in principle, NASA can take it or leave it, but NASA tends, this is the third one that's happened, NASA tends to more or less, and we'll see what that more and less is, listen to it. So I'm gonna, Barb in the blurb said, "Oh, listen to me. You don't have to read the 800-page report." Well, I didn't read the 800-page report. I looked at the summary slides, and I have extracted a lot of those. I've chosen a color theme that is similar, so it's not too jarring for your eye. But I hope it's easy for you to distinguish what's mine and what is part of the official presentation. Nonetheless, the 800-page document is vital that it's that long because it's a document that's designed to be cherry-picked. There are top-level recommendations that people will go after for, like, which missions are we supposed to be doing? I want to do that. And then right down in the details, there's like, well, how does my science relate to what the big picture is? And people have to look at that as well. So the whole thing is useful, but maybe only these two people actually read the whole thing. I don't know. The two people in charge are Robin Canup and Phil Christensen. Robin Canup is my boss at Southwest Research Institute. She's a luminary in planetary science. She's best known for her early work in modeling the impact of the Mars-sized object that hit the Earth very early and formed the moon. Went a long way towards understanding why that was the best idea for the formation of the moon. She's very good in everything. She can understand all the whole breadth of the science. She's an excellent writer. She's a assistant vice president in our company, so she's proven management skills and is the right person to be at the top here. Phil Christensen's a professor at Arizona State University. I think he was an associate professor, maybe assistant. He had to be associate when I started at Arizona State in the early 90s. He actually won his first instrument as a postdoc, and the university pretty well had to promote him pretty quickly. That was on the ill-fated Mars Observer mission that blew up when it tried to enter Mars orbit, but he reflew it on Mars Global Surveyor, and he's also got instruments now on OSIRIS-REx and Europa Clipper, and I don't know what else. And Phil also was the deputy chair of the last decadal survey. So there's a good mix of younger and older, experience here that sort of were at the helm for this whole survey. Let's see, why isn't my advance happening? There we go. Okay, so looking back at the title, Decadal Strategy for Planetary Science and Astrobiology. This is the first time the word astrobiology has appeared in the title of the Planetary Science Decadal Survey. So it's worth just kind of touching on what is astrobiology. It's the study of life, not just elsewhere in the universe, because that used to be called exobiology, but how does life originate? Where is it? How does it evolve? What happens everywhere? It's a big topic. The modern era of astrobiology began in 1996 with the report that a Mars meteorite, a meteorite that was known to be from Mars, from other characteristics, some papers were published saying that there were tiny structures in it that looked like they were microfossils of some kind. And this caused such a huge splash that President Bill Clinton even gave a press conference on it. And the fun thing about that was that scene was basically extracted and repurposed for the movie Contact, if you remember that. But all this has been largely discredited, but it started a huge wave in NASA of many programs. And it's, the whole idea of astrobiology is now integral to NASA, especially in planetary science. I have mixed feelings about this. You'll see these little Bob's opinion things comes up. That's why you're paying me the big bucks tonight to do this. This idea of finding life in the solar system or elsewhere, remains the high risk, high reward. Personally, I think if we discovered life off the Earth, that would be the greatest scientific discovery ever. I think we have more chance of doing it with JWST than with a mission in the solar system. but it's something we should still pursue. The downside for people like me is that every proposal I write has to be framed in terms of astrobiology and life potential. I've always been interested in why are Venus and Earth different, and I've talked to this group before on that. It's a basic question in how rocky planets evolve, but the missions that have been selected now and all the research has to be framed in terms of, well, could there have been life on Venus until it all got fried a billion years ago? So astrobiology is here to stay. So let's talk about planetary science as a whole. The Planetary Science Division is one of 4 divisions in NASA. Its budget is close to $3 billion a year right now. They oversee the space missions, which is the biggest part that feeds back to everything. But there's also ground infrastructure and a big research analysis group. It's presently directed by Lori Glaze, who, just 5 years ago, she was the chair of the Venus Exploration Group, and I was the deputy chair, and now she's pushing $3 billion around, so it's pretty exciting. This is the NASA fleet chart for the Planetary Science Division. So the color of the name of the mission shows where it is. So some missions that are blue are in extended operations, otherwise long in the tooth. NASA never turns off an operating mission. Anybody who's tried it has met with severe repercussions. So those are still going on. Primary operations are in green, things that are flying and getting their main data or on their way to get their main data. Things that are being put together right now are in orange, and then things that are really sort of beginning more are in yellow. The 2 biggest things to keep your eye on, which we'll come back to, is the Europa Clipper. That's the next big mission that's going to go to Jupiter's moon, Europa, an ice-covered world that has an ocean underneath it, and then the Mars sample return campaign, which involves both the United States and ESA. So we have to talk about the buckets that NASA puts missions in, because that's how the decadal survey frames what they recommend. So there's really 3 overall big main classes. The flagships cost billions of dollars. NASA says, we're going to do this. Who wants to come? And they might compete the instrument, but the mission is directed. A NASA center is assigned. It's a big deal. They get this direction now from the decadal survey, but once NASA picks it, it's set in stone. The next level of media missions is called New Frontiers, and it's competed, but there's a specific list. They're big enough that NASA and the prior decadal surveys felt that we can't just have people proposing billion-dollar missions. It's too much investment for the NASA centers and industry, Lockheed Martin and whatnot, to try to do a bunch of these at the proposal stage and only have one, get through. So there's a list that you have to pick from, and the what's happened with how that list has evolved is an interesting story that I'll spend some time on. At the so-called small level, like this is still big, $500 million, is discovery. And these are competed, openly competed. They can go anywhere. You can do anything. And typically there's, 24 proposals that are submitted to every one of these opportunities. They happen 2 or 3 times a decade. So that's where the most, money gets spread out to sort of, the broadest background. At smaller levels, under $100 million, there's a thing called Simplex, which I forgot what it stands for, but they were small satellites. I forgot to tell you what these are. So let's go back to the top. On the upper right, you see the Perseverance rover. That's the latest flown flagship to Mars. In the middle, with Jupiter, you see the Juno mission that was selected under New Frontiers. Next to that is the Lucy mission that was selected under Discovery. Those 2 are both Southwest Research Institute. And then down on the left is the Janus mission, or Janus. That's Dan Shears at University of Colorado. It's 2 small satellites that will go to a nearby asteroid. And then the big thing that's happened at the lowest level is the commercial lunar payload services, where NASA has competed the payloads and they separately compete the landers. and on the right is the Firefly Blue Ghost lander that I'm leading two teams, or one team that's on this lander and one team that's on another lander. So that's the big picture. Flagships, large, New Frontiers, medium, Discovery, smaller. So this is the first official slide from the OWL decadal survey. What they're doing is trying to, it's a big job. They want to look at everything that people could be doing in the discipline of planetary science. They want to prioritize questions, and they want to say, what should we be doing as the initiatives? They want to understand how much it's going to cost to do these different missions. That's this TRACE thing. And then the fact that it's done by the national academies makes it independent of NASA. Okay, and then here's my take on it. Why do they really do this? Well, the number one reason for having a decadal survey is to endorse, in fact, the ongoing NASA mission developments. You can't have a bunch of scientists get together and suddenly say things that NASA invested in the last decade are junk and we shouldn't be doing it, especially when they're multi-billion-dollar investments. So, this decadal survey endorsed the things that were done that were started in the last decade. The past decadal survey endorsed the things that were done the decade before that. The new thing that comes out of this, or potentially new thing, is to name the top flagship mission, the multi-billion-dollar mission, which NASA can barely get one started a decade, to name that mission. That's very important. The next thing, where things get kind of interesting, is to adjust this list of what's allowed at the New Frontiers level, the medium scale billion-dollar missions. Then the thing that most people, use a decadal survey for is, where does my science fit? Every proposal we write, we have to relate back to the decadal survey to some question or investigation in it. So, I just put in a proposal for a new kind of instrument, and I'm burrowing down into how does this relate to what I want to do on Mars or what I want to do on Venus. I got to identify those things specifically in this new decadal survey. And then, of course, they always advocate for a robust budget that allows both the good cadence of missions as well as ample RNA, because a lot of the mission, well, just like we're talking about JWST, right? The mission itself is exciting and sexy, and it's more so a planetary, because like you get there and you do something, but then data can come back over months or years and generations of people can analyze it. And so having that research and analysis funding is important as well. Okay, this is an official slide, which I've annotated in the corner here. About 100 people were involved in this out of our community of several thousand. The takeaway from this is that they had a lot of community involvement. People could write papers, submit them to them. People made presentations. They painstakingly went through all this. They had tons of meetings, and then they finally released the report this spring. I did not know about this chart before Robin showed it during the briefing, that they came up, the steering committee of 20 came up with what they thought were the most compelling questions to be distributed to the subgroups to work on, and those pretty well mirrored what the so-called AGs, the assessment groups, there's several for different worlds. I chaired the Venus group for a couple of years. That the distribution of what questions the decadal was asking mirrored what the community was asking. So the whole buy-in from the community is very important to marketing and the decadal. So these are all the questions. I'm not going to go through them all, but they fall into three categories: origins, worlds, and life. OWL, the wise owl, that was Robin's specific acronym. And so there's all these questions, and each one of these has like a chapter on it. This is where most of your 800 pages is going. The takeaway, which they came up with the takeaways, emphasizing that the crucial role of sample analysis and in situ analysis. We've done lots of flybys and orbiters to different worlds. The ones that we can, there's more of a push now to be landing on them and analyzing stuff or putting probes in their atmospheres. Analyzing stuff in place or bringing stuff back to the Earth. The ice giants are starting to really come into their own. The ice giants are Uranus and Neptune. in our system, and they're probably the most common kind of planet in the galaxy universe, as far as we can tell from things like the Kepler mission. So understanding our own ice giants is really important. A couple of bullets here on the how things evolve, but then at the end, this is very clear that Robin specifically said we want to make progress on understanding if there's life in the solar system in this decade. We've talked about it a lot. We want to go there and do it, and so this is driving a couple of the key things that we'll see. So let's talk about the flagships. And my approach here is not going to be just to show you what's in this decadal survey, but for both the flagships and the new frontiers, to look at how things have evolved over the last 20 years. The first decadal was done in 2003. Before that, NASA, since 1958, just did what it wanted. There were some various advisory groups. One was called Complex, but they didn't really feel the depth of responsibility that the National Academy's decadal survey process really brought in, and that happened for the first time in 2003. And the two flagship missions at that time were a Europa geophysical explorer and Mars sample return. Europa is a moon of Jupiter. It has this icy crust that's I don't know, maybe 10 kilometers thick, maybe 30, maybe less. It's got an ocean underneath. This is known from Galileo. The surface is very active. There's like hardly any craters on it, so it's constantly reworked. There's evidence that plumes, shoot material out into space and on the surface, and it got a lot of attention, earlier. And so the idea that we could send a spacecraft there that would have a radar on it, those are those Yagi antennas you see, also powerful visual and infrared mapping capabilities became the highest priority. At this time, the Mars sample return idea really got some traction. Mars has been its own program throughout much of the modern history of planetary exploration. Personally, I see Mars as first among equals in an oxymoronic sense. It's a great target. We can go there, we can operate there easily. It's had a record of water in the past. It may have life in the present or past. So it's just a compelling target, but it has an outsized presence in terms of the overall science questions that people are interested in throughout the solar system. So the Mars, the idea of bringing a sample back from Mars was logical and began to evolve in earnest in the 21st century. Well, then we got to the 2013 decadal. This is the one that was headed by Steve Squires. Phil Christensen was the deputy chair. The top recommendations were no flagships actually got launched in the aughts, or initialized. But so in 2013, the decadal said, well, we're doing, Mars is still its own thing. We're going to do sample return. So we need to have this Mars astrobiology explorer cacher be the top priority. And that was called MAX-C. And that turned into the Perseverance rover, which is caching samples on Mars now. They changed the Europa Geophysical Explorer to Jupiter Europa Orbiter. I don't know if it was this decadal or the next one, where they shifted from going into orbit around Europa to just orbiting Jupiter and doing a number of close flybys of Europa. It's a lot easier to not have to go deep into the gravity well and actually get into orbit around Europa, rather just keep flying around Jupiter and whizzing by Europa. So that got a start. Europa Clipper is supposed to launch in a couple of years. The next highest mission that was ranked was called Uranus Orbiter and Probe. So going to the ice giants with in kind of a Cassini style, where they're going to orbit and drop something into the atmosphere of Uranus. And then at lower priority, kind of in case everything else fell through or blew the budgets, they listed an Enceladus Orbiter or a Venus climate mission. So what happened from this? Well, in the 2023 decadal, they pretty much kept it business as usual. Again, these are such expensive, high priority missions that if you're going to rock the boat, there's got to be a really good reason. So they strongly endorse continuing with the Mars Sample Return Program. They capped its cost at a little over $5 billion, or they said if it gets to be over 35%, I think, of PSD's budget in any one year, which would be about $1 billion a year. So if it balloons to being more than $1 billion a year, it should be re-examined. I think Mars Sample Return is going to be one of those too big to fail things, like JWST was. So we're going to get those samples. They strongly endorse continued Europa Clipper. It's being built. The interesting thing now is that of this list of other possible missions they could do, or their own, they come up with their own, they endorsed continuing the Uranus orbiter and probe. They strongly considered Neptune as they want to do the ice giants. They strongly considered Neptune, but all things being equal, Uranus is closer, and all things apparently were equal. So this is the new start mission of a flagship for the next decade is Uranus. And then they listed another mission, Enceladus, which is also listed previously, but they wanted an orbiter and I forget if this is an orbiter and a lander, or an orbiter that can land. I guess that's why they call it Orbilander. So that's the story with the flagships. Let's look at the new one briefly. This is the Uranus orbiter and probe. This is their slide. So there's so much that's offered out here at Uranus. There's the planet itself, the ice giant. There's the rings. There's the moons, which are incredible. There's its magnetosphere. And as I mentioned, this is especially compelling because this is probably the most common class of planets in the universe, and they've made the point that there's no new development needed for this. We know how to do this mission. It takes a while to get there, and it depends on what kind of launch vehicle you get, but this looks very promising. The next priority was the Enceladus Orbilander. This looks like one thing, yeah. So it's got one thing that like legs sprout out of it and it lands. This looks like it was probably studied by APL because it looks like New Horizons with legs. Enceladus is a moon of Saturn. It's relatively small, but it's incredibly active, and especially at the South Pole, there are these cracks where the Cassini spacecraft observed material spewing out. I mean, they could actually see it and see it regularly. And they flew through it, and Cassini wasn't instrumented to look for life or even really advanced biological organic molecules, but there were sort of precursor molecules and relative abundances of primitive compounds suggested disequilibrium, which is always a sign that life is in there messing stuff up. So Enceladus is like really promising place to go look for life. So here they are checking off on the top. We got to go to Mars, got to fly around Europa. Okay, we're gonna go study an ice giant. This one we want to go actually look for life. Now, the interesting thing about this is it completely supplanted the Europa lander. So the Europa lander had been under study for a number of years. It was championed by former Congressman John Culberson of Texas. He pushed through money to keep. He helped Europa Clipper along the way. But this is what he wanted. He wanted to be the guy who was responsible for finding life off the Earth, or funded it. I was the beneficiary of some study money here. Our electromagnetic instrument that reached a level of technical maturity under study money for this. We were able to propose it for the moon, and we're flying to the moon now. So this was a big deal. But in this decadal survey, they tossed this entirely and went with Enceladus. Why? Because even though Saturn's farther, it's much easier to go to Enceladus. Europa is deep in Jupiter's gravity well. You not only have to slow down a lot, or actually speed up a lot to get to Europa, but then you got to change your speed again to land. So all that multiplies in the size of a rocket that you need to go there in the first place. I mean, They were talking about using SLS at one point, the new space launch system for this. It would just be wildly expensive. The other thing is the radiation from Jupiter is so intense that this thing would only last a couple of weeks. So meanwhile, Enceladus can go, they can fly around a while, and they can land, and have a great mission. So that, this is the logical thing to do. And it took this panel to make this recommendation to NASA to say, forget it, let's do this. So that's gone. Interestingly enough, this panel strongly recommended 2 medium class missions. So this falls in the category mission that New Frontiers does, that we'll discuss in a while. But they're saying you should do these. And the first one's called Endurance. It's called Endurance A because they gave 2 scenarios, but this is the one that the panel picked. This is a robotic lander. It will be delivered by one of the CLIPS, the commercial landers that are relatively cheap and expendable. It would land in this giant South Pole Aitken Basin, which has been a topic of interest in the moon for decades now. It's the earliest preserved impact basin on the moon, maybe in the solar system. And they would land, way over here and drive 600 miles. I don't know what 600 miles. Colorado is what, 300 miles across? I don't know. It's going to drive like across states, right? And end up going to the South Pole, which is where the astronaut base is supposed to be. So they don't need to send it back on a rocket. They just take it to the astronauts and they pick up the bags and samples and take them back to the Earth. So it's a great integration of human and robotic exploration and adds a big science component to Artemis, the humans, which will have science, but it's mostly about getting the people back there. So I really like this mission. My only concern about it is that this is the strongest endorsement we've ever seen for a medium-sized mission, and I just worry that they'll start directing more things this way in the next decadal survey. The other medium-sized mission that, kind of almost 2 that were endorsed was this thing called Mars Life Explorer. I think they call it Millie. So it's basically a Phoenix / InSight type lander that would have specific life detection experiments on it. And it would land in the mid-latitudes of Mars, where the ice is not exposed to the surface, but is protected at a meter or less under the surface. So they, this fits this theme of we're going to find out if there's life in the solar system this decade. And then they also, talked about there was an idea for an orbital radar ice mapper. NASA canceled this. The decadal survey agreed it had been poorly formulated, but they said, well, you should go back and think about it again. I am not in favor of this mission. As I said, this was pushed through a very small minority group of people were studying this. And I think this decadal, really wanted this life detection stuff this decade. So it kind of went to the top. There's no evidence to me that microbes can survive in cold ice for, up to millions of years and then suddenly wake up and then possibly that ice sublimates over time and goes somewhere else and comes back. So it's a big gamble of a mission that, might pay off hugely. That's astrobiology. The ice mapper was again advocated nearly entirely within NASA. I was not unhappy to see it canceled. Its real main purpose is that they always want infrastructure at Mars. They want something to be orbiting that has a radio link so that they could send high rate data back to the Earth. And that really is what this would do. But that radio comm capability they think can be provided by ESA, by the Europeans. So I'm personally not in favor of either of these missions. They wouldn't happen until late in the decade anyway, and I'll probably be retired. So let's talk about what's one of the most interesting sagas within NASA is the history of the New Frontiers program. I gotta take a swig for this. So New Frontiers is this mid-level of mission that $1 billion is still a lot of money, that you have to pick from a specific list. And the first list that came out was in 2003, and it was the Kuiper Belt, Kuiper Belt's the objects that are beyond Pluto, Kuiper Belt Pluto Explorer, a Jupiter polar orbiter with probes, comet surface sample return, lunar South Pole Aitken Basin, that's the thing the rover is going to go to now, sample return. So this would have been a static lander, grab some samples, rocket back to the Earth. And then Venus In Situ Explorer. This was a fabulously ill-conceived idea as well. It was like a metal balloon that could go all the way to the surface of Venus and then come float around and land and take samples. No way they could have done it for the amount of money. But that's the list. So what happened? Well, the first thing to realize is that in the late 1990s, there was a solicitation from NASA for the Kuiper Belt Pluto Explorer. 5 teams responded. 2 were down selected, one led by Alan Stern, one led by Larry Esposito. And I don't remember exactly when the selection happened, but the NASA, bureaucracy, administration, leadership, evolved, and they didn't want this mission anymore, and they canceled it. But Alan Stern, among others, got such strong endorsement from the Decadal Survey that they put it in as this, this is one of the missions you got to fly. And eventually NASA caved in and said, okay. And again, I don't know, maybe this is after, then they formally selected New Horizons as New Frontiers 1. So that's New Horizons in the upper right. The Juno mission was a new mission to Jupiter. It wasn't just going to kind of take pictures of the system like Cassini did. It was specifically to go close to Jupiter in an elliptical orbit and using gravity and magnetics to study the deep interior of Jupiter, understand if it had a core, and then it had infrared and kind of long wavelength device instrument to look deep in the atmosphere to understand the structure deeper than we could see, or the Galileo probe was able to go. So as far as I know, that was a straight up selection, right out of that list, Juno. The third one that was picked is OSIRIS-REx. This is the asteroid sample return that they just successfully got the samples last year, and they're bringing them back to Earth. It was not on the list. What happened was, in the middle of the decade, around 2005 or 2007, a little ad, I guess it was Academy endorsed, but it was a small panel convened and recommended that NASA should open up the competition to more targets. And I forgot whether it was more specific targets or just like open it up for New Frontiers. And OSIRIS-REx, swooped in and won. So something that was not on the list. It's had a very successful mission, and they should be returning their samples in the next couple of years. So now we move on to the 2013 decadal. So we have these missions lined up already. Now, the 2013 says, okay, let's keep on with the same ones that were there before: Comet Surface Sample Return, Lunar Sample Return, Venus In Situ Explorer. We're going to add Saturn and what's called a Trojan Tour and Rendezvous. The Trojans are a bunch of asteroids that are near Jupiter. They're actually plus or minus 60 degrees from Jupiter. They're kind of like a garbage bin for stuff in the solar system. So a lot of stuff could accumulate there. If you could go there, you could like learn secrets of stuff from perhaps the inner and outer solar system. So they wanted to go there and actually rendezvous with one or more of the objects. And then after something was picked from one of these for New Frontiers 4, then one of these, whatever was left over, could stay in, and then they would add a lunar geophysical network and the Io Volcano Observer for New Frontiers 5. Okay, what happened there? Well, we basically got the Trojan Tour in the form of the Lucy mission for the Discovery program. So what's so great about Lucy was they argued, well, we don't have to actually rendezvous with these objects. We can just fly by. And they developed an orbital scheme that flies by many of these objects. And what's most cool about it is it doesn't really even leave Earth. So when I mean it doesn't leave Earth, it's an elliptical orbit that starts in the region of Earth. It goes all the way out to Jupiter, flies by something, comes back to near the Earth, goes out again. Everything is moved, but they've got it perfectly timed to go by something else. It is rocket science. And so this is why, there's the success of Lucy, because they're doing everything with the Trojan tour without having to spend the extra fuel to get out there and stay out there to catch up with these objects. So it's brilliant. So Lucy, cross that off the list, don't need it, but all of its science is satisfied. Then the other thing that came in was Dragonfly. Well, what's Dragonfly? It's not on the list. No, because in the middle of the 20-teens, NASA solicited, input on opening up new frontiers again. And there was this really cool idea to send a drone basically to Titan. Titan is Saturn's moon with a thick atmosphere, methane atmosphere, among other constituents, and you can fly in it. So this spacecraft will spend most of its time on the ground doing analyses. It has a seismometer, and it'll do a handful of short hops, but it's an aerial vehicle on Titan. But it got there by basically, for the second time, breaking the mold of what New Frontiers is supposed to be. Now, New Frontiers 5, there's supposed to be a selection in 2026. People are starting to write proposals now. Although these are all still on the list, you can imagine. They haven't released the list yet, but they'll probably take this off the sample return because that's going to happen with Endurance eventually anyway. But any of these other ones could still be proposed. So you'll likely see one of these happen starting in 2026. Here's the list that the 2023 Decadal recommended. They're keeping all the stuff from before, and they added a couple more for New Frontiers 6, and then they added this Neptune one for New Frontiers 7. These dates are hypothesized by me. It typically takes 5 or 6 years for NASA to crank one of these out, and then 5 or 6 years to fly it. So I don't think that they've talked about these both happening in this coming decade, but I think we'll be lucky to see New Frontier 6 get selected before this decadal survey runs out in 2032, and the New Frontier 7 will definitely be selected sometime in the next decade. And these missions, of course, won't fly until the late 2030s to early 2040s. So briefly, let's look at what they're recommending for these medium-class missions. The comet surface sample return is to bring back a part of a comet. Very exciting idea that goes back, through 2 decadal surveys now. This was really close to happening before because there was the Caesar mission, which competed against Dragonfly in the final and lost. It's highly developed, and I think it's a very strong candidate to be the New Frontiers 5 selection. Venus In Situ Explorer, I said the original version from back in 2003 was pretty ill-conceived. This was revised to just sort of be, a short-lived lander. Just get to the surface, measure the atmosphere, tell us something about the surface, that could have some possibilities. There was a mission called Vox that was a finalist for New Frontiers 3. I've given talks to this group before. I called Venus the forgotten planet because there had been no, missions to Venus in 20 years or more. But now there's going to be 3. The Veritas and Da Vinci were selected under Discovery. Envision is an ESA, United States joint mission. They're all going at the end of this decade. So I don't think that under New Frontiers 5 or 6, it's likely that they'll pick this. But by the time we get some new results from Venus and can make the case for going to the surface of Venus, this is a good candidate, I think, for New Frontiers 7. Saturn probe, well, sounds good. Let's go to let's put something in the atmosphere of Saturn. Galileo to Jupiter had an orbiter and probe. Juno was not able to afford its probes. They proposed in one with just the orbiter. Cassini, Saturn was an orbiter only. So, if we're gonna understand the giant planets, we need a probe. The Lunar Geophysical Network is something I've been involved in. All these missions had money to do a pre-study for the decadal survey. So this was ours. And so the idea is to put a network of landers that the most important instruments is seismometer, and those would operate for 6 years or more, and build up a picture of the inside of the moon, especially what its core looks like. That helps us understand the origin and evolution of the moon. The instrument I would lead is the electromagnetic instrument that puts out these electrodes to measure the electric field, and it also has a couple of magnetometers. The electromagnetic fields together is how we look inside the moon. Heat flow probe, and then these are some possible sites: 3 on the near side, 1 on the far side. This is a tough sell now, because not only we have the human program Artemis, we have CLIPS sending, they eventually have to send 2 missions a year, and now there's this endurance mission. So how this mission gets framed will be important to whether it has a chance at all. This is new now to this new decadal survey, the Coral mission, Centaur orbiter lander. Centaurs are icy and rocky bodies that are beyond Saturn, beyond Jupiter, strictly speaking, between Jupiter and Neptune. There's a lot of information about the primitive solar system to be learned. This to me looks for all the world like an Apollo lunar module. So I guess I should read the report and see what that's supposed to be. This sounds like a great idea, but to me, this is the same as the Trojan rendezvous, except farther. And Lucy found a way to do that for cheaper. So, more power to them. But this seems kind of that some kind of flyby would do better as well. Ceres is the largest of the asteroids. It's between Mars and Jupiter. It had the Dawn mission visited, which was very successful. Ceres got an icy and a little bit of rock on its surface, but it's got a mushy kind of mud interior. We don't know exactly. It looks like there's eruptions of liquid that have left salt deposits on the surface as the water sublimated away. So understanding what's on the inside of this body would be pretty high priority. I participated in this study as well, and I was thrilled that they were excited about doing electromagnetic sounding. It even got far enough that when JPL commissioned like a cartoon storyboard of it, which I think James Keane did these drawings, they did some cool drawings of it that featured our proposed experiment. So this is the lander. It lands kind of upside down. These are the thrusters for the ion propulsion for getting there, and it has giant solar panels which get furled up for the landing. Once it lands, all the action happens on the bottom. That's where all the instruments are, and then it would shoot out the same electrodes that we're going to use on the moon. You shoot out these electrodes, but they look much cooler when they're drawn by James Keane. So the electrodes go out, and we're look for brines using electromagnetic sounding. And I wish I had one of these Apollo era control panels with a rotary phone dial on it. I just think it's so cool. Very, very nice that they rendered it this way. So this would be a New Frontiers 6 proposal as well. Enceladus multiple flyby. Well, so this is just a flyby, not an orbital, not a lander. You don't have enough money or fuel or rocket to go into orbit around Enceladus. It's going to look more like Cassini, but tuned entirely to Enceladus with its instrumentation and its orbit. And so Enceladus gets twice the love in this decadal survey. They want to find life. They have it listed as a flagship and here in New Frontiers. Titan orbiter. Titan is again the big moon of Saturn with the atmosphere that presumably has liquid in its interior as well. I think it's a little early to be doing this. It would be kind of right after Dragonfly. Would we have enough information about Titan to be worth going again? But it's a compelling world, and we've seen that it can steal the show. The last thing to be added later is this Triton Ocean World Surveyor. Triton is a moon of Neptune that has volatiles that, nitrogen and stuff that moves around its surface. It might have water in the interior, it's a long haul to get to Neptune, especially to go there at a speed that you can slow down and get into orbit. And it is a exciting target for a next generation. The decadal also had a couple of other important areas that they looked at. They looked at the state of the profession, and they made 4 recommendations that although there's been progress in diversity, they need more demographic data of the community to understand, where things stand exactly. We're all subject to unintentional bias, and so learning more about how to deal with that is important. We need more opportunities for everybody and to create an inclusive community. Again, they looked at research and analysis. It's down to 8% of the PSD budget and at a peak of 15%, and they'd like to see it maintain a steady 10%, as would most kind of rank and file scientists. You may have seen the spectacular pictures of Arecibo, the radio astronomy observatory in Puerto Rico, collapsing. That needs to be replaced. That's actually operated by the National Science Foundation, but NASA supports it, and that and other NSF activities they want to cooperate with. And then of course, there's the recurring drumbeat of astrobiology here in the context of, let's get astrophysics involved. They've got JW. Let's look for biosignatures around other other stars. Okay, that's my breathless summary. What's the big picture? Well, this is a big effort by everybody who worked on it. It gives clear direction, and it doesn't throw any big wrenches in the works. It's largely consistent with previous recommendations, and overall, NASA strives to meet the recommendations. I have some questions about how effective the New Frontiers program is as a selection process, but the results have been great. They endorse the ongoing large missions, the flagships. That's Europa Clipper and Mars Sample Return. They're recommending one new large mission, the Uranus Orbiter and Probe. So that's what you'll see started in the next couple of years, hopefully. We'll see 1, maybe 2 New Frontiers missions started this decade. Again, I feel that target list is kind of meaningless when it can be overturned mid-decade. We'll see if that happens. But Enceladus is in the mix in both large and medium, so I wouldn't be surprised to see an Enceladus mission happen. We'll see a couple of discoveries. Those could be anywhere. We will see effectively continuous science from the moon, from CLIPS, from Artemis, and then from Endurance. And then the big picture is things are pretty good. I mean, it's a robust program. The money is solid. Congress and by inference the American people support this endeavor, and that we're ready to draw the next generation of people into this grand adventure. I just note here at the end that this is the 60th anniversary of Mariner 2. This is before my time. I'm in the middle. Everything else is going to be after my time, but it's still a very exciting profession. So thanks for your attention, and I'll be happy to answer any questions. I want the emojis, John. I wanted the chat.
Gee, I'm sorry.
I want the thumbs up with the confetti. Yeah, all that.
Shoot. What do you think? This is Facebook or something? Remember, you're on mute. I probably muted you during that talk, and so if you have questions.
Oh, I think that me.
Oh yeah, I muted you the whole time. You didn't know.
Yeah, you
watched
on
me
mute.
for 25 minutes of mute. Yeah.
Yeah, thank you so much. Really appreciate this, Bob. And I have one question. So with the decadal survey, and I don't, I know a lot more about it now than I did, but so can they change some of these as they get, let's say, the first couple of missions that go out there. And maybe you address this, but I'm not sure, with some of these later missions. So, okay, maybe we found out everything we need to know about, well, that's not going to be true, but about one of these, say Titan or whatever, then will they use some of those funds to try to fund some of these other missions? And then what's their budget? Are they restricted over this decade? This is what you're going to propose for this amount of money, or
Yep,
are they?
okay. So the program, the overall program is designed to be responsive to change. But when the ship is so big, you can't turn it. So suppose suppose there's some big discovery. Well, you're not going to change the missions like Clipper and Mars Sample Return that have already seen, close to $1 billion in investment. You're going to carry through on those. You have the opportunity of picking a relevant mission from the medium missions from New Frontiers, or like we've seen, just adding one in. I mean, they just added in Titan, and I think it's counter to what they're trying to do here, but they do it. But then at the discovery level, still $500 million, those could be anything. And so if something, like I'm interested in a Mars helicopter right now. I'm not part of any team that's studying that, but I know JPL is. And, I think I could, do a ton of great science with it. That helicopter was proven with that little one that just, flew with Perseverance. And, that's an example of, okay, now how can we make that bigger and do science? Well, there's no mission here at the medium or large level that says fly a helicopter to Mars. But at the discovery level, you could propose that to be responsive to those changes. So, the bigger it is, the harder it is to change. And it's a multi-decadal endeavor. So everything just has to fit into the big picture.
And how is that influenced by politics? Because we know that in the past, Houston, Texas has influenced Congress in this budget, and I'm not sure how much. I guess you're saying that Congress approves the budget for the decadal. We know some of this.
Congress approves NASA's budget.
Yeah, and then they let NASA kind of decide, right?
Yes.
But they're influenced by these various states, California, Texas,
Absolutely.
Florida, right?
Yeah. I know it's everybody involved is a human being. And so for example, the people who got Dragonfly, I don't know how much of that was inside of NASA and how much was outside, but they changed the rules mid-decade and then it got selected. So nothing's written in stone. With regard to Houston, that was Culberson. So he advocated a bad idea, the lander, Europa lander, that went away. But along the way, everybody realized that Europa Clipper, the orbiter, was an important precursor. So that had a positive effect. So yeah, it's always political, and you can't predict where it's going to go.
Anyone else have questions? I'm sorry to kind of barge in there, but those were on the top of my mind. Anyone else with questions or comments? John?
I have a question. Bob, could you compare and contrast the radiation environment versus distance between Enceladus and Europa?
I cannot. I can tell you that Jupiter has the most powerful magnetosphere in the solar system. You've
Right.
probably seen the graphic. If you haven't, I'll send it to you. I've seen a graphic. If you could see the Jupiter magnetosphere, it would subtend like your outstretched hand in the sky.
Yeah,
I mean,
degrees, right?
Yeah, it's giant.
Yeah.
And so it's intense. The closer you get, Europa is the second moon, major moon from Jupiter. So I don't know what how many, let's put it this way. I think I remember, I think they specified the environment as something like 100 kilorad exposure total for the mission. And you would be shielded in a box at like 10 kilorad. And the whole thing was supposed to live like 2 weeks. And, so Saturn, by contrast, has a magnetosphere also, but it is much less intense and I think proportionally as well. Enceladus is relatively farther away. So it's, it's just not anywhere near the risk that Europa is.
It's closer, but obviously it's a relative thing.
Yeah, when you look at the moment, divided by the distance or something like that, it's
Yeah.
it's a less thing.
But Europa is
Thanks.
390 million miles from Jupiter, and Enceladus is 790 million miles from Jupiter.
Right. Yeah.
What?
That's wrong.
That's
Well,
wrong.
again, you have to look at what the
Wikipedia is
magnetic
totally
field
wrong.
is. Yeah, you have to look at what the magnetic field is compared to because that's what determines how much trap radiation there is compared to the distance. And then,
Yeah.
The various spacecraft have made radiation measurements, and I can't quantify it, but it's just hands down easier to go to Enceladus.
Takes longer, of course.
Takes longer, but your design phase is going to be a lot easier because you're not trying to cram everything into 2 weeks.
Yeah. Thanks.
I appreciate the idea of having everything laid out far, far into the future because it gives you direction. But what if something comes along like these unidentified bits floating around that turn out to be something very interesting, or if James Webb finds something that's absolutely spontaneously interesting? Is there room in the plan for, oh my gosh, we've got to deal with the aliens now?
So if there were aliens, NASA would deal with them, right? They would throw everything aside to do that. Of course, James Webb is mostly overwhelmingly extrasolar. I mean, it's looking at stars, galaxies, stuff that's far, far beyond what any probe can ever get to. But if another Oumuamua came and actually flew around the sun and braked and went into orbit around the sun, like a certain novel, we would for sure stop everything and send a mission to it. But again, I just want to refer you back to this hierarchy where the amount of time and money it takes for these biggest missions. That's the longest term thing. You get one of those per decade, and then you get one or two of the next level, which you've got some flexibility in, and then you have two or more opportunities for the next level, which can be anything. So the responsiveness, generally is linked to the complexity and size of the mission. But again, if aliens showed up, we would just drop everything and go figure out what it was.
And Bob, the other thing, and that maybe you want to point out here is you're talking about all these missions, and it sounds like NASA, but there are a lot of scientists down in Boulder, Denver, all over the US, internationally too, who are a part of these proposals, just like you are, that, it's not just 3 people, in most cases it's dozens, I'm sure, maybe more. So each one of these missions that have gone into this survey have the background of these scientists, engineers who have all proposed this, right?
Yeah. So maybe I didn't make it clear at the beginning. I mean, the decadal survey is based in the community. So it's overwhelmingly not NASA people, because or I don't know what the mix is, but lots of people like me are at private organizations, overwhelmingly universities. So the people who made the recommendations are a reflection of the community. When it comes to the proposals, those tend to be a mix of NASA and the community. So for example, you always need a NASA center, and that comes down to Goddard, JPL or by proxy APL, which is not a NASA center, but its basic functions as one. You pretty much need one of those three to lead a good sized mission at kind of discovery and higher. So you end up, they end up with a lot of their scientists on, instruments can come from anywhere. So they tend to be very big multi-institutional endeavors that get, bigger as the mission gets bigger. But, any mission can involve a huge cross-section of the community.
Hey, Bob, it's really not the case that the members of the panel there were independent of NASA. They're almost all funded by NASA. I mean,
Okay. I meant NASA employee, so we can explore what the feedback loop or incestuousness is of the panel as a whole if we're funded by NASA. Have at it.
It might be worth mentioning too that this is just one of the decadal surveys. There's an Earth decadal survey, so Earth missions, one for heliophysics that studies the sun and space weather. There's others, or those are the ones I know of that would impact in this area.
Astrophysics, there's an astrophysics.
Yeah, that's true.
There's 4 divisions and they all commission a decadal, yeah.
Clark, did you want to, I think you're muted right now, but do you want to say a few more words about what you brought up there?
Well, no, I think it's sensible that the people involved in the business who understand things make these recommendations. It's just that there's this fiction that's always been there that the National Academy of Sciences is independent. Yeah, but the people that they get on these committees and so on, they're mostly funded by NASA. And I don't mean to say that that's incestuous or anything. I just think that you shouldn't say that they're independent.
Yeah, I meant to say not NASA employees. And yeah, your point speaks to a broader point, I think, Clark, or maybe one that's just, we can't have people outside the industry review it because they don't understand it well enough. We're experts in this particular field. But within the field, when you look at the individual groups, so I mean, we go all the way back to, what are the panels? Okay, so here's the panels that were formed. That already shows how things are going to break out, right? The minute you break things up into groups, you've established the factions and how people are going to advocate, right? So just like anything else, planetary science votes with its feet, and small bodies, for example. Nobody used to care about small bodies. Sorry, Clark, you did, because you were prescient.
Well, explain what small bodies are.
Asteroids, comets.
Yeah.
But it was the advent of the Discovery program that allowed small missions to go to, starting with NEAR, I think, to go to these worlds, these bodies, and develop a huge scientific interest in them. And now, we got a lot of small bodies. So that's changed over the years. That's how the community, votes with its feet. So I think the distribution, it's got to be the hardest thing for the steering committee to get out of their own, discipline and try to represent the community as a whole. That's the level where I hope some independence comes in.
No, I basically agree. I think that's fine. It's just the terminology that's commonly used that you use is what I object to. But no, I think the process is basically a reasonable one.
But after Bob's talk, we're all experts too. How do we get on the committee?
They actually, they had one, I didn't go into it, but they had like one person on the committee who was not in planetary science. She's an expert in, I forgot what she was an expert in. Some human factors, interactions, diversity. I forgot what it was, but she's like a nationally renowned person that they included.
I think it's super important. You kind of mentioned on this, but each of the surveys have been really pushing on the bias and the the diversification of diversity in it, and which I think is hugely important because, I mean, it's just, especially for bias, like some of the proposals that I've seen from the Hanoi Solar Telescope and for James Webb, they can come from, they're sort of anonymous in a way. So they're looking at just the proposal and not the proposer, which I think is a huge, we all have our favorites, right? And so these things matter.
That's very important. I served on my first panel this year where the proposals were anonymous, and the ones I had, I could tell who they were anyway, but it didn't matter because it just made you look, what's written down. At the end, once you rank the proposals, they'll tell you who wrote them, so you can say, well, are they really qualified? Which I didn't care about at that point because I thought the proposal, I could tell whether they were qualified. So I favor this going all the way to just full dual anonymous. People are still learning how to write these proposals because even if I didn't know who they were, in some cases they would leak through, information. And so training everybody how to write these proposals so that you don't reveal who you are is important. But yeah, it's part of leveling the playing field.
So yeah, if anyone else has questions or comments, that'd be great. We still have most of our people here. Not many people have left, but Bob, I had asked Bob to share with us well, you're saying maybe I was right, Tanzania, but Tanzania trip to Africa. And you have some photos and experiences you want to share, right? And your wife Megan went with you too, right?
Yes.
And
this will be
and
like
other friends.
Yeah, this will be under 20 minutes.
Okay.
Let me see.
And I just want to mention this. My brother and sister-in-law who live in Canada, they're a little older than I am. They went to South Africa and then they did a little different trip than you did. And they said, but very similar, about a week or so, they said it changed their life. It changed their perspective just to go there, and they're pretty open-minded before, but
I wouldn't go that far personally. I think for me, it was a trip of a lifetime. I probably won't do this again, but my wife and I being empty nesters now and finally taking a big trip ourselves are more, I think, inclined to want to try to travel now. So yeah, this trip was organized by my longtime old friend Amy. She and her friend, my friend Linda, were turning 60, and they wanted like a bucket list trip. It was supposed to go in December of last year, but COVID got in the way, so it got rescheduled. Barb, I'm sorry if you had the correct pronunciation of Tanzania the whole time, and I contradicted that somewhere along the way, but that's how they pronounce it: Tanzania, Tanzania, Zanzibar. We were mostly in the northeast part around the town of Arusha, down here in Tarangire National Park, and then in the Serengeti. So, I'm gonna show you a bunch of pictures of animals, which you can see anywhere, but these are my animal pictures. So I was there. So, I'm not gonna dwell on them, but it was pretty exciting.
Definitely.
The overwhelming thing, aside from everything with the animals that I got and the trips, was what Kenya and Tanzania are like. They're poor. I mean, the contrast between the tourist bubbles that we're in, the beautiful places you stay, the airplanes back and forth, and what happens on the street, where it looks like people spend most of the day surviving, was stark. So that was really the biggest impression I got of the whole trip. Our itinerary took us through Nairobi first. It just turned out to, worked out that way. We're going to stay overnight in Nairobi and then hop a little plane the next day to Arusha, but we missed that flight, and I'm not going to get into that whole thing. But we had to take a little bus for 6 hours to get to Arusha. So that was the beginning of our African experience. Once we were there, we met our friends in this beautiful villa. They'd been there for a week doing stuff around there. It's within sight of Kilimanjaro. These are colobus monkeys that were right there on the property. We went to this place, Tarangire and Lake Manyara. This is the only thing about the accommodations I'm going to show, but every place was like this. The 3 or 4 places we stayed, were all just sumptuous. At this first part, Tarangire, we self-drove, which is pretty rare. But this is a typical setup as a Toyota Land Cruiser with a pop roof. And this is my wife, Megan. She took all the pictures. I just did the phone pictures because I knew that she would do much better pictures with a real camera.
Yeah, that's great.
Okay, wildebeest. I didn't know much about wildebeest. They're everywhere, and
They migrate too, right?
I'll show you that later.
Okay.
They're just a really weird looking animal, also called a gnu. They hang out with zebras a lot because I think wildebeest smell better, but zebras see better, and they graze different heights of the grass, so they can not compete and hang out together. This is a watering hole in Tarangire. It's actually artificial. I mean, they do it there to bring the animals, and boy, does it bring the animals. Saw a lot of elephants. In this one, there's a juvenile, but at one point we saw one that couldn't have been had to been born last night. These are mongoose, I think. I just thought they were so cool. Then this happens, right? So we saw some lions sleeping. The first day we're all excited. This is the second day, and here comes this lioness stalking up to the water hole. She goes after a wildebeest, brings it down, and this animal actually got away. We did see another kill later. All in all, we saw between 25 and 30 lions. I'll show some of the highlights. It's just too many lions.
Go back 2 slides. That was an anthill? Wow.
That's an anthill, yes. Those are all over Tarangire, but virtually absent in the Serengeti. And I understand it has to do with the difference in the soil conditions.
You'd think the ants would be size of puppies or something.
Yeah, this is one of only 2 lions we saw that had a radio collar on her. This is for Jan Waddington. I've already shown her this picture. This is a lilac-breasted roller, possibly the most beautiful bird in all of East Africa. Megan got this great shot of it. More lions. This lioness is lying in this tree. There's another one over here. She wakes up, yawns, walks down the tree, walks 5 feet in front of the trucks. Okay,
Jesus.
another lion.
You took that, or Megan took that?
Megan took this. Yeah, Megan took
Wow.
it. Yeah, this is right behind the vehicle. There's a
Jesus.
warthog. They actually are called Pumbaa, and they do say Hakuna Matata there. Although I wonder that's only because all the tourists know it. Many giraffes. There's another anthill back there. This one is just. I'm going through these because this is all the first day.
Wow.
Ostriches and wildebeests. I forgot what those monkeys are called. But this is at a picnic area.
Picnic area for monkeys or humans?
Well, for humans, but the monkeys are everywhere. The monkeys these are incredible. They coordinate their attacks. So one of my friends had his lunch stolen, and I'm standing there, and I got a backpack on, and it's sealed up, but this one monkey runs and tries to attack somebody. I turn to follow it. Another monkey comes behind me and hits my backpack. Didn't get anything, but off he goes. I mean, it was incredible. So then we flew to the Serengeti. So this is typical for the vistas out there. First day, here's the first male lion that we saw, or that wasn't kind of far away, just hanging out. What does he do? He climbs up into these rocks and just goes full Lion King for us, like right away.
Now, was he upset with you?
No, he was
just
trying.
doing his
He
thing.
kept trying to get further up and he couldn't. He wanted to go to the very top. But no, he's just like checking it out. These are little granite outcrops. They call them copies, which it's a granite tour for the geologists. They're lion magnets. That is a secretary bird, now called a, I don't know, snake killing bird or something. They look absolutely prehistoric to me. We did a balloon safari. This was the highlight of the trip, as you saw from the cover slide. So there's 2 or 3 companies that do this now. This company is the oldest one. They launch 3 balloons at a time at dawn. You fly right over the land surface. And these guys have done this so many times that they can go up and down a little bit and target the winds and go where they want to. And then they got a GoPro hanging out there in the rigging, so you can get selfies. And the highlight of this, well, there's a hippo right there. But here we come. Oh, so we flew right over this vulture's nest. Amazing. And then we flew over these hippos, so many of them, and he flew like right over this. How do you do that? But there they were, very busy. That's a serval cat. That's a bunch of giraffes. Now we're back on the ground. This is the only leopard we saw. So, managed to check the box on that. The only kind of major well-known wildlife we did not see was a rhino. But this is a good find. Everybody always jokes about the tail looking like a bell pull hanging down out of the tree. That's what you look for. Okay, here's another highlight. So the guide gets, the guides are all talking to each other, and we, suddenly hightail it off for a mile or 2, and right next to the road is this. It's like born free.
Those are babies, or this guy's eating?
Those are babies. Those are,
yeah. Okay.
So
okay.
There was a copy, a little rock hill, 50 yards away. The guide said they were, I don't know if they were a month old or weeks old, and she was just bringing them out for the first time out of the secret hiding place. And, it's like, she's like right down next to the road. Finally, she gets tired of us kind of just like being there and leads them away 20 yards. They plop down again. They're happy.
Wow.
That's a cheetah. Here's your basic, another great lion shot. One of the guys on it, he goes, oh, come on, pout for me, baby. We just got to expect more and more. And so I had to throw something else in here, and that's a hartebeest. Very odd looking animal. We were done. Oh, then here's the wildebeest migration. This was just the tail end of it. We barely caught the end of it. We sat here for half an hour and watched them go by. There was a film crew that said they'd been there 4 hours. And this is still not as big as, what's dramatized, where you see them going across the river and the crocodiles going after them. And that was probably a highlight that would have been nice to see as well. But they're just a huge number of them. So we're done with the Serengeti. This is taken from near our camp. We were not allowed to walk anywhere in camp without a guide, an escort, including one, a Maasai warrior who had like an actual spear and had killed lions with it. And I figured out why, because yes, there was a lion that was in the Kopi, the rocks that were in the middle of our camp. So, all right, we get it.
So were you in tents?
We were
Or-
in tents that looked like that kind of picture that I showed at the beginning. They
Okay.
call it, it's a canvas structure. This one had a canvas floor, but it had, bed, desk, flush toilet, shower, sink, right? It's plumb. It's a plumb tent. So then we went to Zanzibar. Zanzibar is a small island off of the coast of Tanzania. This is from the resort. Geophysically, the most interesting thing is that it had this, 13-foot tide. So when the tide's out, it's going, I don't know, at least a kilometer out here to where the surf line is. And then the natives would come and they're harvesting seaweed and doing I don't know what else. This is a little island off the coast that we snorkeled at. It's under the conservatorship of a German organization. One thing I was intrigued about was the strong German presence still in East Africa. They had a brief period of colonialism in the late 1800s, and they were kicked out in World War I, having never lost a battle in Africa. But there's German tourists in the Serengeti, German language tours, a lot of humanitarian aid that comes from Germany, a lot of conservatorship, a lot of construction and new tourism. So there's still a big German presence here. We walked through Stone Town. This is the original city in Zanzibar. It's constructed almost entirely out of coral. That's why it's called Stone Town. This is the open market. Good thing you can't smell this from the picture. Adjacent to that, we saw where the slaves were held. This is the slave memorial. There was a slaving trade in East Africa that was mainly Arab driven, that wasn't quite as big as the West Africa, slave triangle that came to the United States, but it was very significant. It was a big part of the history there. This is the old fort, now sort of a market. Many people, the only thing you know about Zanzibar is where Freddie Mercury of Queen was born, so the obligatory walk past there. And this is our last stop. It was a restaurant that you had to walk up like 6 floors, open air. You sat and ate, and they played music. And this is me and Megan, and here's Amy trying to get out of the photo bomb. But I just want to, acknowledge her. We love her for setting this whole thing up. She lived in Africa, in Kenya as a kid, and they went on safaris then. She's been back on several safaris herself, and she was a travel agent for several years. So, we just got a smoking good deal on a great trip that she put together. Right. So, we love her. So that was Africa.
Tell us about your wrist.
It's some kind of, I don't know what that is. They put that on you. It's like a lei, the equivalent of a lei, I think, except it goes around your wrist. It was flowers or something.
More economical. Okay, good.
Yeah.
No, Bob, that's a terrific slideshow you have. Let me just comment that Y and I went to South Africa 2 decades ago, and we've traveled all over the world, many places, but the trip to South Africa is our number one.
Is that so?
Had many similarities to what you showed in Tanzania, and I recommend going to Africa.
The poverty contrast. The poverty. What about South Africa and press? It was just going on the safaris. You went to Kruger.
We mainly went to Kruger National Park, to various, big tent like places that you stayed in, but we also went to Johannesburg and to Cape Town, and of course there's poverty in abundance surrounding those 2 cities. And
I lived in South Africa when I was in high school, so it was back during apartheid. It was actually during the Soweto riots, 1976, and the biggest thing that amazed me about South Africa is it didn't end in a bloodbath. And it's got a lot of fundamental problems still, but I'm glad that people can can go there, and I should go back.
Why did you end up there in high school, you said?
My dad took a job with a tire company that had plants over there.
Wow.
Yeah, it was the formative experience of my youth, because I mean they spoke English, as well as Afrikaans and Xhosa and other languages, but I could get by because I spoke English, and yet I was exposed to people who weren't Americans, right? So it was good for growth.
Where did you grow up before you moved over there? Not sure I know.
Ohio, Oklahoma, South Africa, Tennessee, and then Massachusetts, Texas, Arizona, Colorado.
Jesus. You've been around.
I bet he's a lot of people.
Yeah, that's pretty amazing. Wow. And well, I've just got to say, when you were in, this is what SkyWatcher's is like for me sometimes. When you were in Zanzibar, I emailed you, you were just about to leave, and I emailed you and I said, okay, down to the Mountain Messenger deadline here. You want to do the 9th or the 16th? And I got an email back from you from Zanzibar. I think you're on your way to the airport or something, going, yeah, let's do the 16th.
Well,
and
yeah,
that was so special. That was really neat.
Yeah, it's been my pleasure. I mean, people like Y and Clark and many others, you guys have, traveled a lot. I've traveled, but certainly in the last couple of decades, with our kids, it's mostly been, Caribbean and Hawaiian vacations that have water. So for us, we're hoping that this is a new beginning of a new set of adventures that we can follow in your footsteps.
Leonard and I just want to go, to like Santa Fe.
There you go.
Although
Out of your house.
Yeah. Oh, well, hey, we just got a refi, so we're happy with staying here too. But
So, then you want a vacation out of your house.
You should go see Caribou tomorrow, Barb.
Oh yeah, because you two went
Wildflowers are
there.
wonderful there.
I looked at the trail maps last night, so yeah, I wanted to see the wildflowers there. And the other thing, Bob, knowing you were over there in Africa and Leonard had fallen asleep, and I'm looking at National Geographic or something, and I saw, a special about wildebeests migration, the Serengeti. Some of I think the thing that, it was a team, probably not the team that you met there, but that was traveling with these animals. And one of the things was these lions, female lion and young lions, not the little, are they puppies? I don't know, baby lions.
Cubs.
But a little older, and they were trying to catch up with the wildebeests, and they couldn't do that. And some of them were just, you could see ribs on them and everything. So do you think, I mean, obviously that happens, but I don't know if that's rare, you'd think.
Are you saying the Cubs were trying to bring down a wildebeest?
No, well, they were trying to train them. No, these were young, like teenage lions or something. And they couldn't keep up with the wildebeest. So some of them were dying off, and the parents kind of tried to get them to where they could capture something, But I was really surprised, because you think of, but a lot of like animals eating other animals. And
Circle
I know
of life, baby. That's
that's life.
It's a circle of life, just like we all know from the Lion King. Yeah, I mean, I don't know anything about what fraction of lions learns to hunt successfully, which ones don't. There's I think between 3,000 and 6,000 lions in the Serengeti alone, and they have to kill, like, I don't know, once or twice a week. So a lot of wildebeest, so there's, gazelles and stuff are going down. But I mean, I didn't even show you any gazelles. There's so many gazelles there of all kinds. yeah, so, the thing that I want to learn more about is just like, why is it so fecund? Why is Central Africa, I mean, yeah, I know it's like, doesn't have snow. And I guess, there must be a lot of grass that grows that supports the herbivores, which can support the whole food chain, but it's just the variety of life on that savanna is just so diverse and so huge. It's just, why is it so different than everywhere else on Earth? I don't know the answer to that.
Well,
But,
what's sad is-
and this would be interesting to know how this, because I think it's very interesting, but I would rather go to other places besides Africa. But I wonder how much that has influenced, and maybe Leonard too. We grew up in San Diego with the San Diego Zoo and then the Wild Animal Park. So I'm going, I know the lions, I know the hippos, and I went from 5 years old to very many times there. I've seen all those. And
Well, that's why I said, Barbara, these are just my animal slides. They look like animals you've seen. It's totally different being there.
Yeah, I know it is.
The surprise of coming across them, hanging out and watching their behavior in the wild, seeing tableaus of animals where it's like, oh, this animal's here, and then, oh, there's some elements over there. Then there's the giraffes back there. I mean, that's what I haven't gotten all that together yet. It's the vista.
Get along better than humans?
Oh, they're not getting along. They're busy killing and
Eating each
competing.
other.
Yeah.
But
Supposedly
why don't they move further away from each other then?
It's all just perfectly balanced.
Water. They have to go where the water is.
It's exactly. It starts with the wildebeest. They are following the water during the migration, and they go way up into Kenya and way down into Tanzania.
That's amazing. Thank
Hey, Barb.
you so much for sharing that. I was hoping you'd do more than 3 slides. and Susie isn't still on there, Susie and Dave, I don't think, but Megan had sent her like 180 pictures that she'd taken, I guess. And then Susie said, I don't think Megan would mind if I shared these. So Leonard and I did go through those, and I just really wanted you to share those with our group. It's earth science. Thank you, Dave.
John.
Thank you, all of you, but thank you, John. I think he just left us, for doing all this. And I know if you know anyone who wants to buy a house, theirs is for sale. You can go to Zillow, it's on Shimley, or email me. I can give you a link. But yeah, I know they really want to go off in this adventure. And anyone else have comments or anything? And I think our next meeting, I'll just mention that, is probably going to be in 4 or 5 weeks. We would like to get John Grunsfeld, who said he would get back to us about this time of year, and talk more about, and we'll have more images in the next 4 or 5 weeks from the James Webb Telescope. If we don't get him, we'll try to get someone else who knows a lot about that scope and those images and can talk to us. And I think if we could be at the hall, that would be great. I know Bob Grimm, Bob, you really wanted to be there, and I'm sorry we didn't. And we went to the 4th of July and we're okay. We probably could have done it, but
you barely got off the float. So yeah, I know you were still being cautious.
No, then we went down to the parking lot.
Oh,
we hung
okay.
out and drank beer, and Susie said I could bring a bottle of wine since they weren't selling it. So I was belligerent about my bottle of wine. No, it was great, and so appreciate our community for creating something like that. And Tammy, who's sometimes on here, Tammy Waltemath, she's been great about, she was the organizer of the parade and only got one of those little 10 bottles of tequila. She wasn't a judge, so we weren't targeting her to be subscribe. But yeah, and thank you all for being here Saturday night. I know you could be somewhere else, and we had about 28 people on here, so we had a good turnout. So anyone else with comments or anything? Yeah, watch your mountain
Yeah.
messenger. Yeah, John.
Oh, I just wanted to follow up on what my question was earlier on. Thanks for those Tanzanian,
Tanzanian, sorry.
Tanzanian pictures. But yes, they're it looks like Enceladus is about 3 times closer to Saturn, but its escape velocity is about 10 times lower. So I'm sure that's got a factor.
That's half the battle. Yeah,
Yeah.
the radiation is, it's the gravity and the radiation. And the fact that every time they flew by Enceladus, it was shooting stuff into space. Whereas with Europa, there's still this argument about whether the stuff they found, and how consistent is it and how good are the landing sites. So, I mean, everything is better.
Right. For everybody, I have another comment. 2 weeks ago tomorrow morning, I had some fantastic views of Jupiter and Saturn through the telescope. Haven't seen it that good for 10 years, maybe. So
did you take some astrophotography, and can you share that with us next time, maybe? No,
I don't take pictures
It's
through
just-
that telescope.
Oh, okay. Yeah.
It's optimized for visual.
Uh-huh.
So you're just trying to make us feel jealous, right?
Well, is it worth publicizing to the, amateur community that did people get, was it great seeing, and people may have gotten good pictures elsewhere?
Yeah, I didn't see any, but the funny thing is we have these resources now on online for looking up upper level winds, etc. And I don't know. Sometimes they're right, sometimes they aren't. In this case, they had degraded the forecast on one of these astronomical seeing sites and transparency and clouds, but it was better than it was like a week later when the numbers look better. So you just never know. But one of the coolest things was when I first looked at Jupiter, I saw 2 moons fairly, one on each side, and then Callisto was way out to one side. But then the next time I looked at it, Europa had appeared from being in eclipse, but then only 12 minutes later, it disappeared in occultation behind Jupiter. So it's just out for a little bit. And the red spot transited, so that was another cool thing. And I understand that the scientific community still wants amateurs to record eclipse disappearances and reappearances of the moons. So I guess you'd want to do that with a photometer, though, or an imager that you could accurately do the timing of these things, because they take maybe a minute to reappear, and so you want to know where the middle of that is, or the start and the end, so you can get the middle. But that's kind of interesting. I just heard that the other day. So what else?
I don't know much about that. What is not known about that geometry that it needs to be recorded?
They keep wanting to know the numbers better, and I don't know if you know Wayne Green is from BASS. He said that was important, and that JPL actually wanted it for some reason. So I don't really understand why that. Yeah, I thought by now that they'd have that, but maybe there's maybe there's perturbations in the orbits a little bit because of they're all synchronized, right? Io, Europa, and Ganymede are all
Yeah, they have resonant orbits.
yes,
So
resonance.
they're periods of each other.
So maybe that they want to know how much if it's ahead or behind of one of the other moons. Maybe it's it's like a minute off or something because it's at this resonance right now, and it hasn't come around to being in, perfect resonance again. I don't know. Who knows?
I get it.
I did see Enceladus barely, which again is kind of cool because it is really close to Saturn, but it was maybe sub-arc second seen. Titan had a disk, for instance. So
Wow.
yeah, that's only 7/10 of an arc second.
Titan had a disc.
Yeah,
Man.
and it's only like 35 degrees up or something, right? So it was really steady. Yeah, that's all I have. I haven't even looked for the ISS lately. It's just a lot of clouds.
Well, fortunately, tonight the skies are somewhat clear, and I have the news from our household for you. Carolyn is not here because she is at the Gilpin County Fair, where she's doing a star party tonight.
Oh.
And
Tell us though,
that-
well, I could have coordinated this so we didn't interfere with that, but
well, given the weather given the rainstorm that we've had, I'm surprised, but looks like the clouds have cleared up tonight. So
yeah, that's
uh,
great. Yeah, the
probably
storm
just
we had earlier was unbelievable. Did
probably
you get
just
hail over there?
a little, very little, but yeah, rain.
We got a lot,
Anyway,
we're covered. But yeah,
the
please
news-
let us know. We'll let our whole list know, next time she
Well,
does that. I did
yeah.
mention that in my article and the email. We
Good.
want to have star parties,
so
and I was thinking of her.
So the news then from us, she's doing that tonight, and
Yeah.
it's not even dark yet. So getting
Yeah.
there.
Oh, we
So
could go.
She
Come
will-
on,
yeah, she can
gang.
all go over
Let's go.
the Gilpin County Community Center.
Oh,
Anyway,
that's great.
she went to
Thank you.
California last month, the first travel in 2.5 years, because she
Wow.
went to the American Astronomical Society in-person convention that was being held in Pasadena. She had an extra, and she went there, everyone was wearing masks, and, you had to show your vaccination status and all that. And she had an extra day or two before the return trip to Colorado. So she went to Disneyland with friends. So I picked her up at the airport and brought her home, and she tested positive for COVID. So yeah, that's not so good.
And you got it too, right?
And then sure enough, she tested positive. I tested negative the next day, but the next day I started feeling ratty. And sure enough, I started testing positive as well. We
So
quickly
how are
got,
you feeling? How are you feeling now? Are you?
we quickly got the Paxlovid
Yeah.
and took that course. Each of us were feeling, relatively mild symptoms. Like everyone's saying, it's like the worst case of sniffles you've ever had. A bad cold, in other words.
Yeah.
However, we were in the part of the bell curve that has the Paxlovid rebound. In other words, the Paxlovid just delays the COVID. So
Oh.
it beats down the symptoms for 5 days, then you stop taking it. And for us, the symptoms came back and we were testing positive for another week. And today is the day that I have now tested negative for 3 consecutive days. Carolyn has a day or two ahead of me, so she, so we're getting
So she
over
could
it.
do this star party.
Yep.
Yeah.
But for me, you can kind of hear in my voice,
Yeah.
that's where it is, here in my throat.
Yeah. Right. Yeah.
So I'm
I'm
not
so
over it.
glad you're sharing that. And sorry that John Williams isn't still on here. Very similar situation for him. And of course, they were trying to pack up to move too, or to get their house together to sell. But and he didn't even tell me when they were, that was the thing, but I communicated with him almost every day, and he did the Paxlovid too. And then it sort of came back for a few days, kind of almost exactly like you said. And
Yep.
he's fine now, I guess.
You know, and we are just saying the exact same things that everyone else is saying. We've been
Yeah.
so careful for 2.5 years and masking and all this, and still it hit us.
Yeah. Yeah.
Anyway.
You can see Clark shaking his head. Clark and Wayne. They've been very careful too.
Yeah. So
You've-
there we go.
Yeah.
You've
That-
been-
That's the news from our side.
So, and I guess we, you know, I don't know, my brother and sister-in-law got it after, well, they didn't have the second or booster. So they had 3 shots, but they're up in Canada. And they said it was kind of like international jet lag for a week or so. But I don't know, you know, I mean, I've heard people say we're all going to get it, you know, and you know, I don't know. What do you
Well,
think? Is it good to get it?
No,
Even though you had the
because-
shots?
because you can get it again. I
Yeah,
mean, you know,
right.
So you,
Do you think the Paxlovid would be like, if you didn't take that, maybe you wouldn't get it again, or I don't know. Sounds like
No.
you want the Paxlovid.
well, for us, it beat down the symptoms.
Yeah,
So, you know, it was not that bad. But then when you run out of it, then it's a 5-day course. And then when it's over, it's over. And if the COVID comes back, you can't take Paxlovid again. You're done
oh,
with it.
really?
Oh,
And so then you just have to hope that it doesn't get worse. And in our case, it did not.
Yeah, that's
I
But
good.
think-
yeah, but you know,
And-
and of course it's not the immediate thing. It's, are you going to get long COVID? Is this going to be debilitating in the future and all that? No, you don't
Yeah.
want it. But in our case, we got it.
Yeah.
I
But she
think
got to see
intelligent-
Disneyland.
She did. She got to go,
Yeah.
and yeah, she went to the Star Wars, you know,
cool.
the new Star Wars exhibit.
Cool. I
And
think
she-
the intelligent thing about being careful for the last 2 years is that we have waited until the virus became less virulent.
we
And
didn't know going into it,
No,
but
It's
Yeah.
so virulent, it's just not
Yeah.
as,
not
bad.
as, well, whatever the word is,
not as harmful.
we're not as likely to die
Right.
of it.
We're all vaccinated. That's
Well,
the big step up.
Any virus that kills its host is pretty stupid.
Right.
well, yes, but there are people dying from Omicron
There
too.
are.
So,
And AB5 or whatever it is. Yeah. Yeah. It's going to keep
So-
on changing. It's going to keep mutating. And we're either going to keep on mutating with it by stuffing vaccines in ourselves, or we're going to say we can live with it.
well,
Yeah, the
Yeah.
problem is you can't vaccinate everyone in the world at the same time.
yeah, we're all focused on the local people that we know, but yeah, this is definitely a global thing.
You know, I think hearing your story, Mark, and then John going through that, talking to him every day, well, I'm still testing positive. Yeah, it just made me, you know, it was kind of like it's out there. And then I go, wait a minute, John has it, now Mark and Carol, you know, yeah, we're trying to be careful.
Can't hear you,
Leonard
Barb.
grew up, I've told you this before, but Leonard grew up with parents who were chain smokers. So when he gets even a cold or a flu, it really goes into his lungs. So that's why we've been so careful, you know, especially.
And one note to Bob Grimm, excellent presentation. And
Yes,
yeah,
thank you, Bob.
the new Alan Parsons album came out yesterday. It's called
Now I'm all ears, Mark.
it's called From the New World, and it's on Spotify, so go listen.
I was with a couple of friends and we ran into you guys at Alan Parsons, and sat with you, and it was like in the month before COVID. It was like right on the edge.
That's it. And that was the last time we actually went out into public.
Yes.
Because it then hit the following, like couple of weeks.
Yeah, I think it was like January, February. I can't remember which.
Yeah.
Yeah.
Anyway,
Well,
so the new
I'll
studio.
check it out to look forward to better days.
Yep, and the new studio album is out yesterday, so you can get it on Spotify.
That's my vehicle.
There you go. It's called From the New World. And
I don't
he
know
actually does a version of Dvorak's New World and sings it. Oh my God.
Alan Parsons
73-year-old
himself.
guy singing tenor.
He usually had someone else singing all the time on his records.
Yeah, and he started a few albums ago, and he said, well, people didn't complain, so I think I can continue.
Did anyone else hear that for a couple weeks, I don't know, in a row, the #1 song on the Billboard 100, this was just last month, was Running Up That Hill by Kate Bush.
What's that? What's it about?
Well, it's from 1985. That's all you need to know.
Oh, okay.
Yeah.
So what does that say about today's music in general?
Yeah. Yeah.
Okay. Anyway, I'll see you guys.
Yeah, I gotta sign off.
Thank you. Thank you all.
It's been great. Thanks for listening tonight.
Thanks a lot.
Much, Bob.
All right.
Really,
See you next time.
And Tanzania.
Thanks, Bob.
And
Thank you,
yeah,
Barb, for
please
Tanzania. I owe it to you.
Please thank Megan too for taking all those pictures. And if we ever meet in person, make her come to SkyWatcher's.
Yeah.
She's never been there,
Can't make
right?
you do anything. You know that.
Oh, okay. No, that's
Right.
That's how you have a good relationship.
But the pictures
I
were
was-
great.
That's where you ask permission, not for forgiveness.
Indeed.
When you live with the person.
All right,
Thank
see
you
you guys
all.
next time.
Love you all.
Bye-bye.
Bye-bye. Oh, wait, David. Oh, no.
Yeah, you and me,
Yeah.
Barb.
So yeah,
I'm still on.
do you want to, I'm sorry, I should have said something after John did. Do you have access to the telescope? Do you want to? I'll
do.
hang in there with you.
Yeah.
Does it look clear there?
Well, I'll
Yeah.
just take you through it. Can you
Okay.
see the screen?
I can see just you, and then a number of people are still on here. Now it's coming up. Okay.
So what are you
Oh,
seeing? What are you
great.
seeing now?
M8 and M20.
Oh,
Okay.
John, you know it.
Yeah. So what I'm going to try to do is to take you through how I set up my remote telescope to take images like this. We saw JWST images tonight, and they're infrared, but we saw these wonderful color images. So how did that happen? So someone had to take the individual images that are taken through filters at particular wavelengths in the infrared and assign colors to them. So that the Wall and Carina was 6 different filters, which were assigned red, orange, yellow, green, blue, violet colors, and then mixed together in order to form that final image. So that's kind of what I do. Here's one where hydrogen is green, sulfur is red, and oxygen is blue. And they're mixed together in ratios that I think are pleasant and wind up showing a lot of detail where you see regions that might show up being more red or more yellow or more green, indicating mixtures or presence of particular atoms. So if I want to observe, pick a target. So here's the sky right now. And my field of view of the telescope is this yellow box. And here's the Eagle Nebula, and here's the Omega right next to it. So I'm able to get those two at the same time, if conditions are right. So you go check the weather forecast. So here's one I like called Clear Outside. And here's tonight, 2100, 2200, 2300, midnight, 1, 2, 3, 4. It's all green. So they're saying they're forecasting clear sky. We can check satellite images. So here's the GOES satellite, and it looks like all the clouds that are near where my observatory is located, right here at the top of the boot heel of New Mexico, almost into Arizona, is cleared out. And then see what the all sky camera is showing. All the white dots are black or bad pixels. But here's the Milky Way across the sky. So that says it looks pretty good. And I go back to weather station just to make sure. Here's a map of humidity over time. And a couple of days ago, there were some instances of dampness. So it was raining right then. So I want to make sure it's not raining right now, and it's not. Here's when the sun was up, so it's set. That's a good thing. And then I can check temperature outside and the temperature of the sky. And if the temperature of the sky is pretty close to that near the ground, indicates that there's probably clouds, but there's not. So that looks pretty good. So then I can check out my observatory. So this is inside. A couple of telescopes on a mount and a roof that rolls off. And we'll just do that.
Is this just your telescope, or do you share it with other people?
This is my telescope. So I rent the observatory.
Do you rent it year round or just for certain times?
Year round, because my equipment is pretty well nailed down there.
Yeah.
So I'm illuminating this with a monitor on a computer. And I don't want to have a lot of stray light while I'm observing. So I'll just turn it off. And so right now I'm talking to my telescope control computer. So this has control of the telescope mount, all of the cameras, filter wheels, focusers. So I've got the roof off, should be dark now. Moon's going to come up in a while and we'll get some illumination, but pretty much nothing there. So I can start looking for targets. And first thing I'm going to probably want to do is focus the telescope. So here's an application on my computer that's connected to my mount. And I can point to particular targets. And let's see if I can move to Antares. Here's where my telescope is pointed. And it was looking off on the east side of the pier. So it's got to turn itself all the way around and then come back to be pointing at what I want it to.
So David, we're recording this. And that's great. But yeah, I'd love to have you do this as part of one of our, as a highlight, one of our,
Well, let's see how it goes.
okay.
So I'm supposedly pointing there. There's always the surprise of the night.
Yeah.
So here is now the screen that's controlling the camera on my telescope. And let's see if we see anything. So I'm taking a 5-second exposure. And here's the star Antares. And it looks pretty weird.
Oh,
It's got an X marks the spot.
I know what that is.
Yeah, so this is called a Bantonoff mask. So on the front of my telescope, I have a cover, and the cover has slots in it. In fact, it has 3 different sets of slots. Each one of those cause diffraction patterns that then converge at the star. And if they all come together, the star is in focus. Well, it's not. So let's kind of play with the focuser and see if I can get this middle line to line up.
You got a
So that
little-
all 3 of them come together. So I've got a motor focuser on the telescope.
How much latency do you have before, how long do you have to wait before sending another command?
Commands go immediately because I'm talking directly to that computer.
But then it takes a while for you to see the result though, like 5
Right.
seconds.
Because it's a 5-second exposure. So I've got to wait at least that long in
Yeah.
order to. So I click during a 5-second exposure. It'll be moving when that one updates. And then I'll get another 5 seconds until it's centered. But looks to me like I've got a pretty good focus on my telescope. So I'll go back over to my telescope mount. Pull up the right window. And this is the gadget that's causing the diffraction pattern. And I'll take it out of the beam. Okay, so now, while I'm over here, let's go to the target that I want to observe. And what I often do is find a star right in the middle of the field of view that I want to go to. And the particular star in the middle of the field of view that I've found is HIP 89938. And so let's go over to HIP 89938. So hopefully,
David, what program are you using right now?
this is from Cloud Makers, and it's called Astro Telescope.
Oh, cool.
That's for Mac OS. So you can
Okay.
see it supposedly went over here to in between these 2 objects. So we'll go over to the telescope. And we see a different field of view. I don't know where HIP 89928 happens to be, but what I'll do is I'll bring up an application that looks at this image, determines where it is, determines where the telescope is pointed, and corrects the telescope pointing. So I'm pointing exactly where I want to be. So I'm taking a 5-second exposure of this field of view. It's now trying to figure out where I'm looking. And it takes, I don't know, good part of a minute sometimes. I think I'm pretty close. That looks like the Omega Nebula, and that looks like the Eagle. So Omega here, Eagle over there. Still processing. I think I give it 5 minutes to find where it's going. So this is why this is experimental, because things like this happen. Like, why isn't it solving in a reasonable amount of time today?
That's so interesting to see it live, you know, how you're controlling.
Okay, well, while we're looking, let's see if we can figure out where my star actually is.
I see M17 in the field.
Can you see there
Yep.
and there?
M16 there,
Well,
I think.
okay, done. All right, so I'm going to take another frame and let's see if they move where they were. So here's that star. Boom. So it corrected it just about that far. So I have focused the telescope. I've pointed at the target that I want. And now I can start taking images. See, anything else I want to do? I want to make sure the camera is at a cold temperature. So I've cooled it off to 0 Celsius, which is about as good as I can do when outside it's 32 Celsius. Still
Really?
pretty
That's
warm.
pretty warm.
Yeah, it was 40
Nighttime.
earlier today.
Wow.
Okay, here's the sequence of images I'm going to take. I'm going to take a 600-second exposure, take 4 of them of Eagle Omega with these gains and offset with an H alpha filter. Then I'm going to refocus, take 600-second exposures with an oxygen 3 filter, refocus and take images with a sulfur 2 filter. So we'll do that and we're on our way. So now we have a lot of time to wait while this thing is processing, but we can go back over here and look, see what we're looking at.
So you have your auto guider already running?
I don't, so let's do that. I can go for a number of minutes without guiding, but for 10 minutes, that's probably pushing it. So
the auto guider, that isn't just your basic tracker, is it? Because you know you get.
well, there's guiding and tracking. Tracking is when you're following where you think it is, and that's what the telescope's doing right now.
Right.
And then there's a guider that has its own camera looking at your field of view.
So, John, is this similar to the software you use, or?
No, I don't have any of this. This is way beyond what I have. I just take short exposures with Canon utility.
Oh, that's a great app. So that's what I do at star parties for imaging. I take like 30-second exposures
Right.
for that.
I have a really low budget mount by today's standards, so no auto guide or anything. I just take short exposures and take
Mhm.
like 30 or 40 or 50 of them or whatever.
Yep. That's a great technique.
And is this your 6D camera also?
No, this is an ASI 6200.
There you go. Oh, that's yeah. That's the big sensor, correct?
Well, it's a full frame sensor,
Yeah.
highest quantum efficiency, lowest read noise.
Yeah, that's a pretty recent camera, I think, that just came out, what, less than a year ago or a year ago?
Well, actually, I got mine in January of 2020, but I got
Okay.
the first one from OpCorp. So here's the way guiding works, Barb. Is this application is called PhD for Push Here Dummy, and it's pretty straightforward. This camera actually picks off a light beam from the main telescope that's outside of where the main sensor sees the sky, and takes that beam and sends it to a small camera, and that small camera then looks at this and analyzes where stars are. And actually, I've got it set up to look at multiple stars. Okay, I know that, and I connected. Here comes a satellite through the field of view.
Oh, cool. Wow. Can you tell which satellite it is?
You can look them up. There's a
Yeah.
great app called Heavens Above. We could probably do that.
Right. Yeah.
You know, Heavens Above, I've actually done that where I've been outside and you see a satellite and you go back in and look it up.
Yeah.
And say, you know, a certain part of the sky saw this and it'll tell you which one it was.
Yeah. And we have radar 24, for just airplanes. Actually, Carolyn Collins Peterson, Mark's wife, told me about that when we were trying to figure out.
So when you know,
I think it was, yeah. So we can do that just for the airplanes. I don't think that software does satellites.
Yeah.
But it's pretty interesting,
It is.
Yeah. We were looking at when the planes were dumping water on the fire, and
ooh, what fun.
Yeah, right.
Those would be interesting paths.
Yeah.
Wow.
And then they went up to the top of Mount Thornton over here and moved some poles. I think it was United Power down to the end of Camp Eden, down our road here. And I actually tracked it. It keeps coming up on my computer because it's one of those things where, they made probably, I don't know, maybe 15 round trips so you can see the path of it.
Yeah, the terrain was so severe that it was cheaper to fly the poles in. That's just amazing.
Yeah. Then yeah.
So here's how my tracking is, or my guiding is going.
Okay.
So red are errors in declination, and blue are errors in right ascension. And so this is 2 arc seconds, 4 arc seconds, 6 arc seconds. And the total RMS of the two is 0.67 arc seconds. Since my pixels are 2 arc seconds across, that's plenty good.
Yeah, really nice. Is that typical for your mount?
It's got encoders, so it does pretty well.
Yeah.
So we got 2 minutes left. What else can I show you in 2 minutes?
So
So-
do you very often go down to the telescope there, or can you control everything and it's all set? How long have you had the telescope there?
I installed it March of 2021.
Okay.
So I think I've been down 4 times.
Yeah.
And
What have you
that's-
had to do? Or just to visit it, or did you have to make
No,
adjustments?
that was because things happened.
Yeah.
Well, yeah, things happened, and I didn't like some of my images, for
Hmm.
example. So I used to get really bright halos around the stars.
Hmm.
And so I replaced those narrowband filters with others that don't do that to get rid of that property.
Is that
The
because the coatings or something?
yeah, the problem was the anti-reflection coating on the non-active side of the filter
Okay, yeah, it sounds
was not
cool.
good enough, so you get an internal reflection.
Right.
Okay, temperature is coming down. It's 30.6 now outside. And inside it's 31, which is probably rounded from 30.6.
Well, that's not too much different.
Yeah. Minute and a half till we see if indeed I was looking at the right thing. Well, I'm pretty sure because you can actually see the nebulae there. But a lot of things can go wrong in 10 minutes. You can get a gust of wind come by, blow them out, cause stars to streak.
Have the bats on the telescope.
Yeah.
Well, I have a astro imaging buddy who's always telling me about his adventures, and he's at his house mostly, and he has problems all the time. So when you're remote, I'm sure that it doesn't make it any easier.
Mm-hmm. So 3 weeks ago, the roof automatically opened all by itself in the daytime during a thunderstorm.
Oh, no.
And all of that equipment there got soaked.
Jeez.
And only one thing failed, and that was an external disk drive. The computer's fine, the telescope's fine.
Oh.
It's amazing.
Huh.
I figure there was an inch of rain.
Oh,
And the problem
Yeah.
was the motor controlling the roof was too smart, and it had this wireless capability, and it detected lightning and decided it was time to open.
So do you have, oh, look at that. That's great. Huh. Neat.
that's a
Pretty
pretty
good.
good image for one
Exposure. So
uncalibrated exposure.
Yeah, I like to go for background. So see how much faint stuff I've got there.
Huh.
So yeah, lots of little faint details. So that's pretty good.
Yeah.
And then
that's
we'll see.
great.
Hey, David, how many minutes is that?
That was 1 10-minute exposure.
Oh,
And is this with your Vixen lens?
No, this is with a Borg. What do they call it?
Red cap?
It's a 107. It's got a ED doublet and a triplet focal reducer in the back.
Oh, nice. It looks really sharp corner to
So-
corner.
Yeah, so it's 420 millimeters focal length. And what
Mhm.
I've done with the Vixen VSD 100 is I put a focal reducer on it. So it's 300 millimeters focal length.
Mhm.
And then I put a camera with large pixels on it. And that's the one for going really, really deep for exposures.
Is
So
that
I'm
down
pretty-
there also?
Yeah, they're both on the spar, side by
Okay.
side. So the next thing I'm going to do is fire it up and do the same kind of thing.
How much attenuation do you get with all those filters in the line?
Well, there's only one filter. And it's about a 90% transmission at its wavelength. But they're only about 3 nanometers wide. So let's see if I can explain that. So visible spectrum is what, 400 nanometers to 700 nanometers. It's 300 nanometers wide. And this filter is 3 nanometers wide. So it throws away all but 1% of the background light. And it lets through only the wavelength of hydrogen alpha, this particular one. Does that answer your question?
Okay, I was muted. Yes, that was my question.
Mhm. And then these are refractors with lenses. And the anti-reflection coatings on the lenses are like 99.8% transmissive. So even though there's 16 surfaces in there, you only lose a couple of percent of your light transmitting through all those lenses. Unlike a reflector, where mirror coatings are 80 to 90% typically. So you throw a couple of mirrors in and you've lost a lot of light. So these are pretty sensitive. Okay, so that's my show
Okay.
for how I set up and take an image. I'm going to go set up another telescope and observe with it. If you want to keep watching, or do we call it a night?
Well, I guess I'm host since John Williams isn't here anymore. I could let it go. I think Leonard and I want to eat something, but I can just mute it for me, and you can keep going if the rest of you. We've got about 6 people on here. There's
Okay.
Dewey, Brian Miller, Judy George, and Mark, and then John Astolis.
Yeah,
So
go ahead and set it up and we can come back and you do stuff and come back and see the result.
Okay, I can do that.
Yeah,
John,
and
this is the Vixen I'm setting up.
Okay, cool.
I was eating while you were doing your 10-minute whatever it was, so I am ready to watch.
Did you see the image?
I did. While I was searching, I was eating.
Oh, okay. But you saw the hydrogen alpha image with that telescope of
I
the 2
did.
objects.
I
Okay.
did.
So do you have a second telescope in that observatory?
Yeah, there's 2 of them mounted side by side, different focal lengths. The one that I just brought up first was 420 millimeters. This one is 300.
Okay.
What's the imaging camera on this Vixen now?
This is a ASI 2400 color.
Oh, okay.
And
That's
I
a
have
smaller sensor,
and-
I'm pretty sure.
It's the same. It's full frame.
Oh,
So you can see, here's the two nebulae, here's the Eagle, here's the Omega,
yep.
closer together. And you can see some color.
Mm-hmm.
I need to focus this guy. So I need to zoom in on the star. I can't put the Bantonoff mask back in because it would screw up the other telescope because I have the two of them on one arm. But this looks like a pretty darn good focus.
Yeah, that looks great.
Off the bat.
Pretty close. Maybe not perfect, but close. So you're getting a lot more imaging done now?
Oh boy. So once upon a time, I used to go to the nearest dark site that had a place where I could stay and set up my telescope and had power.
Mm-hmm.
And I do it around the new moon.
Right.
And, I observe, set up and observe for maybe at most 6 nights around the new moon.
Satellite on the right.
Yeah, cool. That would be a really high one. So let me get this going and then I'll come back and tell you the story.
Yeah. I'll just talk while you're doing that. I think, for my own opinion, you wait around a lot for a good night, and if you're traveling like you were, you can get out there and get skunked very often.
Rarely, because I would see where the best area was that had a good 10-day forecast and then go there. Does that
So
make sense?
do you have a
Yeah.
camper or something you stay in, or just
No,
a
I'd
hotel?
have to stay someplace that would entertain you.
Yeah.
And one of the things is power. So I needed to have a lot of, sufficient stable power to run my telescopes. And mount and computers, and also it was great if I could find a place that had internet. Okay, so let's start this guy. Four degrees C, that's pretty close. Okay, so this guy's taking this long exposure. So anyway, I got to see some interesting places around the West. Park, Nebraska, Cliff River Springs in northern New Mexico. Let's see, town in West Texas, a place, a resort in northern Idaho.
Wow.
So that was kind of fun. But more often than not, in order to get to clear skies, I was south of I-10. Either Marathon, Texas, or Rodeo, New Mexico.
Mm-hmm.
And so I decided, when COVID struck and I really didn't want to be driving a lot and staying in motels and who knows where, and shopping in convenience stores where people didn't care, that I just set up my equipment at this particular facility that hosts amateurs and has roll-off roof observatories. And since I'd visited there a couple of times and set up my telescope on a pad outside, they knew who I was and what kind of things I did and how big my equipment was. And when I finally said, yeah, I'd like to set up there, they said, oh, Well, we have an observatory just for you.
Great.
And so some of the observatories have as many as 12 piers in them with 12 users simultaneously. And the roof automatically opens at sunset and automatically closes at sunrise. And then you run your telescope. And then some facilities have 2 piers and some 3. But I've got my own and it's wonderful.
I bet. It's great.
Do you have any particular sky projects or equipment projects that you're planning?
Yes. So I do a couple of things. One is I'm trying to get all of the sharpless objects that are larger in size than half a degree, 30 arc minutes or larger. And I'm down to only a handful that I don't have yet. And in fact, these are 2 of them that I don't have with this setup.
Okay.
So then another project is to look for integrated flux nebulae.
Oh, yeah.
And so let's see if I can get this as animation here.
Yeah, I think I'm gonna leave this on and
Okay.
mute it and take my video off, and you guys can go ahead and I'll come back. But
Okay.
we just want to eat something.
So
here.
we're about 7 minutes away from an image off that second telescope.
Okay, I'll be back,
Mhm.
but I'll leave this on for the rest of you. I
Okay.
think we still have about 6 people here. Or 9.
So here are examples of integrated flux nebulae. And I didn't know anything about these things until
Yeah.
I actually set up down at Dark Sky, New Mexico. And the first night I had the telescope set up, I said, well, what am I going to take a picture of? And it was pointed at the North Star. So I said, well, let's just take a picture of the North Star.
Yeah, it's got a lot of, yeah.
There's the North Star right in the
That's
middle of this thing. And this is just stuff around it.
Now, how long of an exposure integration is that represent?
So these are 10-minute exposures and I'll observe all night. And then
So the one you showed us was
them all.
stacked up, yeah.
Yep.
And since it's Polaris, you can do it all night.
Polaris you can do all night.
Yeah.
Here's an area that's kind of, well, it had a fair number of galaxies in it.
Oh, yeah.
These are trying to find one that has M81, M82 in it. No. So here's one that has a little bit of reddish stuff, which is the hydrogen emission.
Mm-hmm.
This is called the Angel. Yeah, and here's M81 and M82. So you kind of get an idea of how big this field of view. This is a 10-degree field of view. 20,
sat-
20 full moons across there.
Is that a satellite galaxy in the above M81?
That's an
near the edge?
NGC. That's an NGC galaxy.
Yeah. I think it might be related to or in, the system.
Hmm. Could be. Okay, so that's, you can stack images different ways.
Yeah.
And if you do intelligent stacking that looks for what's common among all your images and what's not, then you can get rid of things like satellites and whatever. But you can also undo that algorithm and say, let's just take the brightest thing, the image with the brightest light at that given pixel, and put those together. And that enhances meteors and satellites.
Oh, okay.
And so this is what happens if you take several hours of exposures and stack them to bring out the satellites.
Now, is that up towards the north also?
Yeah, it was about 80 degrees north.
Where we're gonna get, at least in the summer, that's where the satellites are the worst.
Yep. This was
so-
probably April.
Oh, well, you'd think that, the sun would be down farther in April. But
This is the same image. Yeah. So it's the same field, same data set, stacked differently.
now, yeah, on Photoshop, I don't know what you're using, but on Photoshop, there's all these different stacking methods. And one is median stacking, which gets rid of satellites. But I guess it increases noise to a degree. Do you have any comments on that?
Yeah, I don't know the algorithm that's used in AstroPixel processor, but it's a variant on median.
Okay.
And somehow it's able to kind of do a better job averaging. Medians work pretty well when you have a dozen or fewer images.
Okay.
Greater than that, it doesn't increase your signal to noise much. And so this algorithm has an ability to roll in averaging when you get to a large number of images.
And what's the name of that again?
This is AstroPixel processor.
AstroPixel processor. I see there's a little bit of the hydrogen alpha visible in M82 there.
Yeah.
That's really cool.
Yeah, it looks like a monochrome image, except for that almost. All right, let's see how we're doing over here. All right, we got an image.
Very nice.
All right, so it says its average is 900. So let's make this 1200, say. And the minimum is 578, so that's pretty good. So pretty good brought out background, which I'm trying to do. And the nebulae actually in the center isn't saturated. It's only a few thousand out of 65,000.
It's a nice background. I mean, it's not very noisy.
Yeah, that's pretty amazing actually with well, it's dark right now. The moon hasn't risen yet. So let me check the sky brightness. 21.88, that's about as dark as it gets. So that's a measure of magnitudes per square arc second. And due to air glow, 22 is about as dark as is possible. And 21.88 means it's really, really dark.
So I'm guessing you would consider this a Bortle 1 sky.
It's Bortle 1, yeah.
Yeah. For those who haven't heard of that term.
So here's clear outside, and they say Bortle 1, 22 magnitude. Yep.
Yeah.
So that's, that's why I'm there.
Yep.
So the integrated flux nebulae really require a dark sky because those are broadband in order to bring out those clouds.
Yep.
So rather than the 3 nanometer filter that throws away 99% of the light, I'm using 100 nanometer filters for red, green, and blue. So this is pretty good.
Dave, is this still near the Polaris position?
No.
Oh.
So the Polaris, I was just showing off integrated flux nebulae images. So here's where I am here in the Milky Way with the Omega Nebula and the Eagle Nebula. This little computer is pretty busy. So that's the field of view of the longer focal length telescope, the one that gave us that monochrome image. And this is the field of view of the one that's doing the color imaging, a little bit bigger. Does that answer question?
Yeah. Yeah.
So we're pretty far south. So what does it say? Declination of this object is minus 15. And even from New Mexico, it's 37 degrees above the horizon. So what I'm going to do tonight is I'm going to keep imaging until it gets to the meridian. And then the telescope needs to swap sides of the mount in order to look on the other half of the sky. So I'll be around when it crosses the meridian to make sure it points in the right direction, and then observe from there until about 4 o'clock in the morning. The meridian is right about midnight. There are automatic routines to do that, and I just downloaded one, but I haven't tested it yet. That automatically take the image of the field of view and plate solve, recenter up. It's pretty slick.
Yeah. So do you stay awake until you're done, or does it automatically shut everything down?
I need to manually close the roof.
Yeah. Okay.
So I just shut everything down and do that. I suppose I could automate that. But I'm typically getting up about that time of day, so I'll shut it down at 5 a.m. and go for a walk. And I typically sleep in between. So I'll set it up at say 9, sleep until midnight, do the swap, sleep until 5 and shut it down.
So if it starts raining, do you have a detector or what?
Yeah. So here's the weather station, and it has a dampness sensor. So it knows when it's raining. And so here's over here on the left, there are a couple of spikes where it rained back on the 14th. So if that had happened while I was observing, it would have automatically closed the roof. So that's one condition for automatically closing. Another one is if the average wind speed gets above 20 miles an hour, it'll close. And then another one is if the humidity is 90% for 5 minutes or longer, it'll close.
It's pretty neat.
Yeah, I could set it up to close at sunrise too. Maybe I should do that. Yeah, you really need to have that information, and an all sky camera is really important. And unfortunately, the best all sky camera quit on the 4th of July with its last image in the middle of this thunderstorm. So that was bad news. We think we blew out the active cable to it. We've got to replace it on order. We've got 2 other all sky cameras that are marginal. You can see the Milky Way. The good one, you can see zodiacal light all the way across the sky. I don't know when moonrise is. Moon rise 2307. So we've got almost another hour before moonrise.
You're shooting H alpha on the one camera though, I guess, right?
Yep. And I'm figuring I'm going to go all night with that. So I'm planning on after the moon rises. But yeah, I could have gotten 2 hours of broadband exposures. One thing on the list to try would be to take narrowband H alpha and then take broadband red and use the red as a background and subtract it off the H alpha to make it so your H alpha image was absolutely pure. That sounded like a dubious.
No, I had to think about it for a minute. I guess, yeah, then when you wanted to add that into your final image, it would be a much better addition to the rest of the image, I'm guessing.
Yeah, whatever details you'd see in H alpha would probably be crisper, is my thought.
Yeah. I know a lot of people do like an H alpha channel when they do maybe M33, M31, other galaxies, just to try to bring out all those regions.
Yeah, and add that to RGB.
Yeah.
Mhm. Yeah, I've done narrowband on galaxies. And that actually has worked pretty well.
Even in the other
But-
colors.
Yeah, but you're wasting a lot of photons.
Yeah.
Um,
David, do you know offhand how they are, what filters they're using on the JWST for their different color channels? I know they're even mixing like the mid camera with the near infrared camera, and it seems to be the information's a little bit sketchy on, you know, how they're generating those final images.
actually, it's all there.
Oh, just a matter of
If-
finding it.
It's where it's finding it. So, so who would like to know that?
John.
Anyone else who's online want it?
What was your question?
So this is what filters JWST are using for their images and what colors are assigned to those filters.
Oh, okay.
This is Brian. I'd be interested as well.
So do we have a mailing list for Cold Creek?
Oh no. You could, I know you could message me on Facebook because we're both on, you know.
Well, I'm about to
friends
send it to
there.
you. So if I had other email addresses, I can just type them in.
Well, you've got mine.
Where is that?
Copper.net if you still have it.
Dewey.
Yeah, I'm not John Williams though.
Mine's Miller Aloha Yahoo. Put it in the chat. Thanks. Yeah, I always used to
Hey,
wonder with the
there's-
Hubble images whether they were assigning colors for beauty or for actual information.
Okay, I'll send that.
Yeah,
Spell
thank you.
check. Okay,
Thank you.
now chat. There go. Chat. It's a big message. It won't paste. Ugh.
So David, where is
Yes.
this? In relation to Magdalena, this site, is it far away?
By New Mexico standards, no. But it's a few hours away. Magdalena is off towards the VLA west of Socorro. And this is quite a bit farther south. Maybe I can just point them out. So here's New Mexico. So dark sky, New Mexico is kind of right here on the boot heel. And then, then here's Lordsburg, Deming, El Paso, Las Cruces. Which one of these? One of these is Socorro. This one. Then you head west. So in here,
Okay.
several hours.
I think Socorro is farther north than where you're pointing.
Well, here we're getting up into Belen and
Yeah, right. Oh, okay.
that kind of
Isn't
stuff.
it
So
wrong?
one of these is TRC and one's Socorro.
Yeah.
So TRC, Socorro, maybe. And over there.
You can see Albuquerque for sure.
Yeah. So who asked the question about Magdalena?
I did, Mark.
Yeah. Oh, okay. Are you a member of Magdalena Astronomy Club?
Well, no. I've
Do
been
you
meaning to.
do you get their emails?
No, not. I've been trying to find their site. If you've got it, you can send it to me at my.
Okay.
Yeah.
They were planning on doing something for trying to bring back Enchanted Skies.
Right.
And I don't know.
Yeah, I talked to Briggs. They've got a plan for a pretty small gathering.
Okay.
Yeah.
So you're in touch. It's
Yeah.
Magdalena Astro.
Okay.
They're, I think the Albuquerque Club is having the Astronomical League convention at the next new moon now.
That's
Boy,
right.
That's a big deal.
Yeah.
Of course, it's right in the middle of monsoon season, but other than that.
Mm-hmm.
Yeah, it's at the end of the month. I was thinking of going.
Okay, are we waiting for Barb? Nothing new and exciting is going to happen here.
Okay. Well, thanks, David. I'm gonna head out, but this is a really fantastic setup you've got.
Oh, thanks.
Yeah.
This is really cool, man. I got a kick out of this.
Seem
So
to
I
have
will-
it running well
Yeah,
too.
I'll process these images, and somehow I have to get the word out that I've done that.
Send them to Barb.
Yeah, she can let us
Yeah.
all know.
Yeah, that'll work. Yeah, so next day or two, I'll have enough time to get them processed.
Cool.
By the
Well,
way,
thanks
I
a lot,
did
David.
get your email. Thank you very much.
Welcome.
Okay, thanks all. See ya.
Yeah, thanks, David.
All
I'm
right.
heading out too.
All righty. Welcome.
Bye.
So I'm not looking. Do we still have people online or are we just waiting for Barb?
Well, it says 5 participants.
Wow.
So I don't know who they all are. It's me, John, but no, there's some, you have some really awesome images. The first one that you pulled up when you started, which was looked like a final image of the area. Well, it had M8 and M20 in it. I thought the contrast in the dark regions, oh, that was really superb in my humble opinion.
Yeah, if you don't really see what you want in one image, you're probably not going to see it when you process.
Well, especially when you're shooting 10-minute subs or you have the sky for it. You know, these
Yeah.
people that take 20 hours of exposure to get M101 from a Bortle 6. Well, you
Yeah.
know, I mean, you can do it in probably 5 hours in a dark sky, right?
Yeah, true.
I hope I
So this,
wasn't bugging you with too many questions.
oh no, that was great. And you could tell that I quit when I had to do something. This is last night, by the way.
Wow.
So this is with the Borg, with hydrogen alpha as red, oxygen 3 as teal, and sulfur 2 as white.
Ooh.
And why did it? Okay, so let me bring that back.
Did you also, do you share my opinion that it was really cool seeing those spectra of the galaxies, and they had it looked like H beta next to O3 and the redshifts on the JWST images?
I didn't see that.
Oh, it was in one of those videos where they were talking about all the different images, but they kept showing H alpha, or well, they showed hydrogen as, you know, they just threw a spectrum up there, a real crude spectrum, and there was a hydrogen and an oxygen, but the hydrogen was right next to the oxygen. I thought, well, it's got to be H beta, but they're showing it as red anyway, you know, just because hydrogen's always red. So
Yeah, well, they don't see H beta or H alpha for that matter, but they
yeah.
do see bracket alpha and Fund alpha out in the infrared.
Yeah, well, these were all at different infrared wavelengths.
Yeah. So if you go through those filters, you can see which ones. You've got
So
those for references in the future.
yeah, right. And I think they're using like a diode array to get those redshift spectral images.
Interesting.
How do they figure out being not really knowing, but how do they figure out how much shift there is to figure out where the lines are going to be when you see them, when they're trying to get the stuff that's way back and that was generated so long ago?
Well, the pattern of the two emission colors is similar, and so they just look for that pattern. In my opinion, I don't know, David.
Well, you know, the really ancient stuff, Lyman alpha from the ultraviolet, is shifted into the infrared,
Right.
and it'll appear at some random place. So I guess they just see where it shows up in the spectrum.
Yeah, I think that's why they're showing the hydrogen and the oxygen, because they recognize that pairing, and so they were looking for the pairing of the two lines. Does that make any sense?
That makes a lot of sense, I think.
Well, I don't understand, because their relative positions, unless they're coming from different places, unless they're using oxygen from someplace nearby in the galaxy without much Doppler shift to compare to the hydrogen from some ancient galaxy.
Well, they're using the hydrogen and the oxygen from a tiny galaxy that's so far away that it doesn't subtend much angular size. So, there's a lot of O3 and like from all the planetaries and things.
Mm-hmm.
And then the hydrogen. So, they know where those appear adjacent to each other, and then they look for the pairings somewhere in the infrared. That's my guess anyway.
So
And they
it might
weren't.
help them identify. So
Yeah.
you see a random unidentified feature, you don't know how distant the object was, what its Doppler shift would have been. And if you just see a single line out there, what is it?
Yeah.
But if you see a
exactly.
pattern, then you know.
That's what I'm saying. Yeah.
Yeah, that makes a lot
No.
of sense.
And then the thing is too, you were mentioning Doppler shifts. These lines weren't really that sharp because you got the galaxies are rotating, right? And they weren't like 3 nanometers wide. They're quite wide.
Mm-hmm.
Because of that, I in my opinion anyway.
So we're actually coming up on a couple of things happening. I'm going to change what I'm doing on this telescope, on the color. I'm going to change the color balance to one that might give me more dynamic range.
That's interesting. Take some of the red out, maybe.
Yeah.
I see you have a block there for a dew heater. Do you need to use a dew heater ever down there?
Never.
Mm-hmm.
Okay, that one's going. Ooh. So this one's trying to focus for another wavelength. So it changed filters, and the filters don't focus at the same place.
Close, but no cigar, right?
Yeah.
Mm. Is this 03 now?
Well, it completely failed.
Bummer.
That's too bad. So I got to start it over.
It's too bad the SkyWatchers aren't, well, you have a bunch of technical people, but just sitting and listening to what the discussion has been since everybody else left just brought out so much technical information on astrophotography and other stuff that I had never learned before. But it would just bore the heck out of other people, I guess, who aren't interested, right, John?
Yeah, I mean, I know something about it, but I know enough to ask a few questions and maybe a few stupid questions. But yeah, I haven't delved that deeply into it myself because I know it's a big learning curve. Steep learning curve.
Yeah, a lot in the processing.
Yeah. Processing is huge. And I think that, well, like learning PixInsight is extremely time consuming, wouldn't you say, David?
Yeah, so I downloaded the free versions of PixInsight and Astro Pixel Processor and decided that I would do Astro Pixel Processor.
Is that for is that just specific for the Mac, or does that work on a PC?
Yeah, it's cross-platform.
Oh, okay, thank you.
My
don't
control
know.
software is specific to Unix-like machines. So it'll run on Linux and Mac OS.
Uh-huh.
I'm doing an autofocus for oxygen 3 now on this telescope. And you can see this star getting sharper or less sharp from time to time as it goes through focus.
Mm-hmm.
And then over here in the bottom right, there are plots. One is how bright the center of the star is. And then circles that show full width at half maximum and half flux diameter. Half of the flux is inside the circle and half is outside. And the autofocus routine uses combination of the peak intensity and the half flux diameter to determine focus quality. And then it goes through a hunting procedure where first it takes big steps and then little steps on each side of the best focus to zero in on it.
It looked like it was pretty close there for a bit.
Looks like we hit it right on the money. If we could have quit right there, it would have been good.
While we're doing that, I'd just like to say that before, when most of the SkyWatchers were still on, and I mentioned how steady my views of Jupiter and Saturn were, I didn't want to explain, the 5 to 10 minute reason why I don't do pictures with the scope, because I'd lose a lot of people, just like, there's probably a lot of people that wouldn't want to be watching this.
Yeah. I've never looked through the Borg 107. Wouldn't know how.
Well, this is my 12-inch visual Dob,
Yeah.
and the main reason is that the focal plane is so far in that you can't get a camera in there. I mean, theoretically, if I had one of these little tiny 1.25" cameras that slide, a planetary camera that didn't have any bulbous end to it, does that make any
Yeah.
sense?
Yeah,
It
those
might,
ones that are used for guiding. It's just like the one I have. It's
yeah,
1.25" and slides in the eyepiece holder.
yeah, I could get it in there close enough because I've optimized everything for visual. Like I made the diagonal small so
Oh,
that
yeah.
the
So the farther in, the smaller the diagonal needs to be, less
well, it
obscuration.
can be, yeah, right, allowed to
Mhm.
be. And so if I had a bigger diagonal, well, the view wouldn't be quite as pretty, but then I could get the focal plane out where I could use it for more things. But it's set up for visual, and it's like about once a year that you'd even think to take images because the scene is so crummy, in my opinion.
Oh, along the front range, yeah.
Yeah.
Mhm. All right, so this guy's off doing oxygen 3 now,
Yeah, I
and
see
it
that.
went through the autofocus, so
And
you
it
can see
finally,
how it kind of
yeah.
went back and forth, and seesawed, and finally wound up here. And then the half flux diameter is the red one, and it didn't seem to get much better as it converged. But anyway, so it's now happy.
Do you shoot for a certain number that you like in those, like the peak intensity or anything?
That just depends on the star I happen to pick.
Oh yeah, because that's the brightness number. Oh great, my cat has found my clean laundry over on another chair.
Of course.
I didn't manage to take that upstairs yet.
Oh, this is the new color balance.
Oh, yay.
Boy, that's a lot more neutral, isn't it? I like this. Wow.
So is this just kind of an experiment that you've just done this time?
Well, there's a group of us in the Longmont Club who are astro geezers. 3 of us have telescopes down at Dark Sky, New Mexico.
Okay.
And we get together once a week just to talk about these kinds of things. And one of them this morning sent me an article that said, oh, if you're using the standard factory software developer kit for ASI cameras, you could be facing this situation. And I thought, well, that's interesting. And I took some test images during the day, and sure enough, that's the case, and came up with the settings I wanted to try tonight.
So
which are these.
Was that on the sky during the day or something?
I've got a piece of perf board on the wall, construction board, whatever, that I use for flat fielding.
Yeah.
But boy, this is a lot better, isn't it? Now I have to get new flats.
Yeah, but you're set for that at least.
Yeah. So what I do is in the roll-off roof rolls to the west.
Hmm.
So just a little after noon, I roll the roof part way off so that light's coming in and illuminating kind of the east wall of the observatory that then scatters and lights up my flat panel, which is on the south wall. And then I use that for taking flat fields.
So apparently your camera can take a short enough exposure for your flat then.
Well, yes. Typically 10 milliseconds or so.
Yeah. Sounds about right. So these images aren't automatically flat divided or dark subtracted or anything, are they?
That's correct.
These are just raw subs.
Raw subs, no darks, no flats applied.
It's a pretty, there's not much vignetting in your field, I'll have to say.
Yeah, it's pretty amazing for a full frame camera, isn't it?
Yep.
There's a reason for that.
Oh,
and
okay.
It's expensive.
A very large 3-element focal reducer.
On the back
Maybe.
of a ED doublet, yeah. And this one is a 3-element focal reducer on the back of a 5-element Petzval. So there's 8 altogether.
Oh, it's already a 5-element Petzval. Yeah, okay.
Yeah, this one is really nice because you don't with a true Petzval, you don't have to worry about back focus. You don't have to get the distance from the last optical element to the camera down to the gnat's eyelash.
I see. This is interesting.
Okay, we were just looking at the focus image. We weren't even looking at the data.
Huh. Yeah, I'll just say for anyone else who's on that
oh my God.
Wow. It's a pretty deep image. That, you know, like you have your standard 2-inch adapter for a large visual eyepiece. With a full frame sensor, usually that isn't big enough to get an unvignetted field of view. So what David and I were talking about means that you need something specialized to get a decent image. Like a 3-inch focuser, maybe.
Yeah, that's what's on the Borg 107.
Nice.
And Vixen is a 60 millimeter.
Uh-huh.
Boy, I like this image. All right, so while we were shooting the breeze, did we get an oxygen 3 on the other one?
Don't know.
106 seconds to go. Should we hang out here and see what oxygen looks like?
I think I can handle another 106 seconds.
I don't think it's going to be very interesting. I don't think there's a lot of oxygen in either of those, but we'll see.
By the way, we have Leonard and Barbara are still on. Otherwise, it's just George, you, and me.
Okay. But Barbara's having dinner.
I think they probably had dinner. Yeah, or doing dinner, right?
But we haven't
I
heard
did
him.
dinner while the meeting was on.
I
Since
think
I'm on,
they just left it on because they're, let me check here, let me check.
Yeah, to record it.
yeah, they're hosting.
Yeah. So if they died, it would kill us. So
Yeah.
they left it on so it wouldn't kill the Zoom.
Yeah. So Barb did say she was going to come back. "24, 23.
Maybe we should scream, Barb, come back, come back.
There's oxygen. There's a lot of oxygen there. Yeah.
Yeah. Yeah, I've seen some close-ups of those objects where they've used the Hubble palette, and you can tell there was a lot of oxygen, like in M16.
Yeah. There didn't seem to be a lot of oxygen around the field of view. Oh, it's pretty bright in the middle of the Omega.
Mm-hmm.
6000s.
Yeah, I was looking for that. Where do you see that? Where your cursor was?
Way down in the left-hand corner.
Oh, look at that. I was looking over on the right side where it says the max and the average and the min.
Yeah, so that's a sort of a pseudo histogram.
Yeah, isn't 65,000? That's probably the burned out full well count.
Yep.
Okay. You still planning on using your 6D system for anything?
I use it from time to time. It's just pretty versatile. It's color.
Yeah.
And you can put a dual band filter on the front of it, do narrowband stuff. So it's pretty handy. I had it set up a couple of weeks ago.
Nice. Well, I guess if we get another comet to come by, it would be handy to
Oh boy, just having
use.
color.
Yeah.
How do you like that?
That's now is what are we seeing here?
Oh, come on. It's the pillars of creation.
Right, but is
And
this
then you
what
can-
is this what you just took?
Yeah.
Okay, you just magnified it. Yeah.
That's pretty good for a 107 millimeter aperture, don't you think?
Yes. Yeah, you
So you
should
can
get
see,
some.
go ahead.
Oh, I was just gonna say that when you get all your exposures done, that ought to be really nice.
Yeah, we can look at the hydrogen. Take a while, but I'll get there. Yuck.
Ooh, focus.
I don't see the features.
How wide is your filter compared to that histogram? Oh, it went away, but
I don't understand.
well, that histogram showed quite a range of nanometers. But I thought your filter was somewhere in there that would just take a slice. I must be wrong.
Yeah, the
Well,
histogram is showing how bright, how many counts we get at each brightness level.
Yeah, but what was the other one before that that had a different abscissa? It peaked in the center.
I think we were looking at the oxygen, weren't we?
Yeah, so
Yeah,
looking
one
at,
like that. Now, is your filter that wide? I thought you said your filter was fairly narrow.
yeah, that's not
Yeah.
a plot versus wavelength. But it's pretty narrow. These are 3 nanometer filters.
Well, that's what I thought, but it looked like that one. And I just was not understanding the plot, I guess, because it seemed like that plot was a lot wider than 3.
Yeah, it's not a wavelength plot.
Okay.
Yeah, it looks like we just didn't hit the focus that good and then it drifted out over time.
Yeah. So have you noticed that the focus drifting?
Yes.
No.
So I go maybe 40 minutes. I'm recording focus versus temperature for each of the filters, and I can set it up the focuser so it will automatically change its focus according to the ambient temperature.
That's pretty slick.
Okay. So we got the oxygen was pretty darn good because that autofocus was just before we took the images.
Yeah.
So we're about to get another one in a minute. Let's see if it fuzzes out some.
Have you looked at any of the, I don't recall. I thought that when we looked at the first hydrogen alpha images, they looked a little sharper.
Yeah, as I don't know, I should have described what I was doing, but I stepped through all the hydrogen alpha and you could see them getting farther out of focus as we
Okay,
went through the series.
Yeah, you know what you're looking for.
So this telescope, the Borg, has a 200 micron tolerance on the back focus.
What's the F number?
3.9.
Yeah, it's is that good enough?
That's not focus. That's getting the distance between the last lens and the camera correct.
Oh,
Then
okay.
you focus it.
Well, yeah, no, I understand what you're talking about. You're talking about the field flattener distance to the focal plane, correct?
Yep.
Yeah, that's really critical. I know.
But for my Newtonian telescope, I have a coma corrector, and it has to be 55 millimeters from the focal plane. But you know, it could be 57 and still pretty good.
Mm-hmm.
But this thing has got to be 200 microns. So I spent a week, the end of May, beginning of June, working on that down there.
The same friend I was referencing quite a while ago now, who does all this imaging, had an F4 reflector that he had a coma corrector on, and he was having some degree of difficulty getting that dialed in properly for his imaging.
Yeah, that's what mine is.
I think he had a 8-inch Explore Scientific.
Have you seen mine? It's a 2006 era Meade LXD 75, which is a
No.
Schmidt Newtonian
Oh, yeah.
that has a spherical primary and a corrector on the front, which is the difference between a sphere and a parabola.
Right.
But one of the really neat things about it is that the secondary is cantilevered off the corrector plate, so you don't get diffraction spikes.
Right. No, that's cool. I know of what you're talking about. I have not seen it. But you still need a coma corrector on that, right? Is what you're saying?
That's correct.
No, that's a different animal than the one I was talking about. So he found out that the focuser and the whole tube of the system, this is Explore Scientific, just wasn't rigid enough to get a really decent image across the whole field.
Oh,
But
wow. Mhm.
yours must not be anything like that.
It was from the factory. I replaced it with a moonlight focuser,
Okay.
a Crayford.
Yeah. Yeah.
So
He
that's
did
pretty
some
solid.
tests.
Mhm.
The tests he did was he put it on one side of the pier and collimated everything. Then he flipped it over on the other side, like doing a meridian flip, and
Mhm.
things weren't lined up anymore. So yeah, you know what I'm getting at.
Well, there's,
Well, things like that happen, people expect they can get a really good system for a small amount of money in the astro world. But then again, there's my 12. Up to about 10 years ago, it wouldn't hold collimation depending on elevation, or, if you're 20 degrees off the horizon, it would be at one collimation. You take it to the zenith and it would be different, just because things needed to be adjusted better or nailed down better.
so that's what you did, is you nailed things down.
Yeah, that's it. No, I did a few things, but like, well, right now I put in a new a couple years ago, I put in a different spider that I built. The spider vanes are only 12 thousandths thick, and I put a counterweight on the other side of the diagonal so that these thin spider veins wouldn't, bend and cause a larger spider diffraction.
Mm-hmm.
But then, of course, I changed the balance of the scope because I was adding weight and da 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 da. It's always something. So, what are we looking at right here?
This is oxygen, and we're looking at the
Okay.
whole field of view. So that's the
And
one that had the nice pillars of creation.
right,
Shall we zoom in on the omega and see what it looks like?
sure. Now you only took one or two images of this so far, right?
Well,
On the
we've been
oxygen.
talking, and it's been cruising along, and it says 3 of 4.
Okay, and then the moon will be up. Or it
Yeah.
is up. I don't know.
Oh, it's an entirely different kind of structure in the middle of the omega.
Yeah, this is very reminiscent of the filtered visual view through a telescope.
Uh-huh.
Yeah, I wish we had a better, a darker parking lot to view from the Coal Creek Canyon, what is it, community center. let some of the folks see some of these things a little better.
Yeah, there's a lot of area lighting around there, isn't there?
Yeah. I don't know if you've been around, but a couple times I've taken my green laser and shined it on the sensor of the parking lot light.
Yeah, I saw you do that.
Oh, okay.
Gives you a breath of dark sky for a little bit.
Yeah. But anyway. I think I'm gonna soon wrap things up on my end. But this is quite a nice thing for you to share with us. I got a lot out of it. I hope everyone else did, but who knows?
Yeah, oh, both of us.
Well, there were a few more on
Yeah, a few earlier.
Yeah.
Yeah.
Okay, good night, everybody. Thank you.
Hey, good night.
Good night, George.
Bye, David. Bye.
All right,
Bye,
now
John.
just wait for Barbara.
Oh, she'll
Well-
come. She can turn it off. You wouldn't have to wait.
I guess that's true. I just bail out. Send her the results.
Yeah.
Oh, I have a quick question for you, David. Haven't you posted onto Facebook in the past Spaghetti Nebula?
Yeah. So you know AstroBin?
Yes.
So I'm on AstroBin. Just look me up.
Yeah. Yeah, I can look at stuff for free. Even though
I
I'm
think
not on it.
and yeah, anybody can look at what's there. It's just posting.
Mm-hmm.
Um,
Yeah, that's I think that's a one of those let's see. You mentioned the name starts with an S before.
CMIS 147.
Yeah, that's one of those objects that you're trying to get the larger ones taken care of, if I'm not mistaken.
Oh, Sharpless. Yeah.
Sharpless. That is that a Sharpless or no?
I don't remember whether it has a Sharpless number or not.
Yeah, okay, no biggie. But you're right about that. I just recall, I remember that number just because I've seen other. That takes a lot of hours of exposure, I know.
It's really faint. It's really faint. And you get into, okay, if I diminishing returns, well, I'll expose longer, but the longer you expose, the more things that can go wrong during the exposure, and then you lose exposures.
True.
So, yeah, I pretty much stick to 10 minutes.
Well, you get plenty of satellites in 10 minutes anyway.
Yeah, but those AstroPixel processor deals with those just fine.
Yeah. Yeah. I don't know. I don't know how they're planning on dealing with that at the Vera Rubin telescope. I know they have some issues that they've been bringing up, but they're in a totally different league.
Yeah, their baseline observing program, I don't think allows for these sophisticated techniques for punching out satellite images, because they take an image and move on. It's really, really fast telescope.
Yeah. Well, and then they have all this AI they're going to have to use to do preliminary processing. I think they're going to be generating 6 petabytes of data per night.
Wow. I've got to change hearing devices. Are we here?
I can hear you.
Oh, good. I can hear you too.
It looks like a, yeah, some, what are those called? Well,
Well,
you have a different headphone on.
These are iPods now,
Yeah.
where I had ear pods before.
Ear pods, that's what I was thinking of. Yeah, I'm not into the Apple, so, or that technology, so I forget the names now and then. Anyhow, yeah, I think I want to try to hang it up here myself.
Okay, well, I've got a few, you can, I don't know if you can see the screen
Yep.
coming up on the Meridian. And I'll flip it over and go to bed. Come back at 4 o'clock, turn it off.
Well, sounds good. Oh, thanks again for doing that. Appreciate it.
Yeah, enjoyed talking with you.
Yeah, good talking with you. And one of these years, maybe we'll get back up to the community center. Who knows?
Yeah, I'm a little scared. So
Well, you haven't gotten COVID yet, right?
even if I had, but no.
I haven't. I just got boosted again in about 3 weeks ago. And I don't know. I haven't gotten it. I went to North Carolina in early June, and everyone was coughing on the plane, but I never got it. So I don't know.
Mhm. Well, I've been on 2 plane trips, but one of them to London.
That's right.
And that's kind of put your mask on in the morning and realizing I'm going to have this on for 13 hours.
It gets a little uncomfortable after a while.
Yep. But it worked.
Yeah. Okay. Well, we will be talking. Thanks
All right.
again. Night night.
Night night. I think I'm going to hang up, Barb. Show you the data sometime later.